I, Vineet Singh Kushwaha, Organizing Secretary, on behalf of the Organizing Committee of this 6 days Faculty Development Program on GenGeo AI, Synergizing Generative AI, GIS, and Smart Technologies and Sustainable Agriculture, feel honored in welcoming you all on the last day and 6th day of this FDP organized by IPS College of Technology and Management, Gwalior, with the support of AICT Atal. The program serves as a symbol for our unwavering commitment to advance professional growth, achieving academic excellence, and nurturing lifelong learning. Hence, we are proceeding to the 11th session of this 6 days faculty development program. I invite Dr. Surendra Kumar Sharma, scientist and engineer, Indian Institute of Remote Sensing, Dehradun. But before his speech, I take this opportunity to present bio sketch of Dr. Surendra Kumar Sharma ji. Dr. Surendra Kumar Sharma is a scientist and engineer in the Urban and Regional Studies Department at the Indian Institute of Remote Sensing, ISRO, Dehradun. With deep expertise in UAV remote sensing and photogrammetry, his research spans 3D reconstruction and visualization, image stitching, spatial data cube development. Dr. Sharma's academic background includes a BTech in Information Technology from KIIT University, followed by an MTech and PhD in Geomatics Engineering from IIT Roorkee. Over the course of his career, he has contributed significantly to both academia and applied research, beginning with roles in industry and higher education before joining ISRO. Since 2022, he has been serving as scientist and engineer at IIRS, where he continues to advance innovative methodologies in geomatics and UV-based remote sensing. Dr. Sharma has an extensive publication record, having authored numerous papers in conferences, journals, symposia, and book chapters, reflecting his active involvement in the scientific community and his commitment to advancing in the field of geospatial science. I invite Dr. Sharma to deliver his talk on AI/ML for sustainable urban planning. It's over to you, sir.
Thank you, Vinny sir. Very good afternoon to all of you, the organizing team of this IPS College of Technology and Management, Gwalior, and especially Dr. Akshay Pandey. In this this talk, I will discuss about the use of AI and ML technology for sustainable urban planning. So you might have heard about this AI ML. Many of you participants might have heard, but I will touch a little bit upon what is AI, what is ML, and what is the different technologies that can be utilized. And finally, I will discuss certain case studies and how this AI ML can be utilized in urban planning or sustainable urban planning. So I'm sharing my screen. Is it visible? Is it visible? My screen?
Yes, sir. It is visible now.
Okay. So first of all, let's talk about what is sustainable urban planning. Sustainable urban planning aims to balance environmental, social, and economic dimension. So many times it happens like development is happening, but we are not considering the environmental impact or social impact or economic impact. So in sustainable urban planning means we have to consider all three. Like development needs to happen, but we have to consider these factors also, environmental and social and economic factors also we have to consider. It ensures efficient land use and minimizes negative environmental impacts. So what happens? In case of sustainable, if we do not consider sustainable development, in that case, environmental impacts are neglected. But we have to use our land efficiently. At the same time, we have to minimize the negative impacts. For example, you must have seen this problem of air pollution, or nowadays in India, it is very commonly it is happening like flooding is happening. So why it is happening? Because they have not considered an environmental impact during when they are developing the things, when they are developing the city, they have not considered those factors. Third is the sustainable urban planning. It promotes climate resilience, resource efficiency, and inclusive development. Inclusive development means we have to consider all the parts, all the each and everyone in the society. Okay. Next, why sustainable urban planning? Why we are considering this? Why we are focusing on sustainable urban planning? So first one is because of rapid urbanization, India will have around 600 million urban residents by 2036. So there will be huge population in the urban cities or urban environments. Unplanned growth, it leads to the congestion, informal settlements, and infrastructure stress. What happens? People are migrating to the urban areas or cities for the better life, for the job. But what happens? The in the city there is a limited number of resources. So you must have seen very common problems like traffic congestion is there. House is not there, though. That's why people are living in the this informal settlements. They are finding certain place and they are living in temporary structures. So this is a problem. Again, another problem is what happens. We people are selling their land for house. For example, you might have seen the nearby city. Small patches are there. People are living there. They are bought some plot and they are constructing their house without any following any guidelines. So this might again will create problem, because if settlement will increase, like people will new house will be constructed, so they have not considered how the rainwater will flow. How, so because of this problem, during the rainy season, flood will come. Environmental threats. So when we are developing the city without considering the environment, so we are cutting the trees and we are not maintaining the blue green infrastructure. So what happened? Urban heat island is the common problem. The meaning of urban heat island is during the night time, what happens? The surrounding area of the city has less temperature compared to the uh, city inside the city. Then reduce green space. Because of the green reduction in the green space, this type of problem, like temperature is increasing. Like in the last year 2025, we have seen in the Dehradun city, it has recorded the highest temperature in the month of May. uh, so this type of problem will occur because of the reduction of the green space. Again, because of the reduction of the green space, the pollution will be another problem. Climate risk is another problem. Flooding, extreme heat, water scarcity affecting the cities and sustainability. Resource management needs to optimize land, energy, water, and mobility systems. So when we are not considering the sustainable development, so what happens? That we have limited number of resources. So we have not thought in that direction. If we are not using the sustainable development to how to optimize the resources, how to use the energy properly, how to use the water properly. Better governance is another requirement. So what happens if government is taking certain decision or government is making certain policies? So if we are not developing the cities using sustainably, then we will not be able to implement those things. So without sustainable planning, cities become inefficient and unhealthy. Inefficient means, like you have seen, the traffic problem is very common problem. Unhealthy, air pollution, flood, all these things are the comes under the unhealthy of the city. Sustainable planning helps us to manage resources smartly. So how to manage the resources smartly, that comes under the sustainable planning. Improve livability. The resident of the city can improve their life. Build resilience urban environment. So we need to develop city in such a way that if anything, any type of like flooding or extreme events happen, flooding or heat, this type of heat waves, these type of things happen, then city can handle those things. So if we will develop in the cities in sustainable way, then this type of problem can be handled. Then comes a role of AI and ML and remote sensing and sustainable urban planning. So how we can use AI and ML or remote sensing for developing the cities in sustainable way. So AI and ML and AI ML or remote sensing form the backbone of modern sustainable urban planning. So how? because remote sensing can provide a huge amount of data set. Each and every time we cannot collect the data set from the ground, so remote sensing is a way to get the data through either satellite or drones or other platforms. And the data, once it is captured, it can be processed, and the information can be extracted. And once the information can be extracted, based on this, the extraction of information, the decision can be made or policies can be made to make cities sustainable. So AI and ML algorithms make sense of this data by automatically identifying features such as building, vegetation, roads, and water bodies. For example, in a particular city, I want to know what is the status of vegetation, like how much percentage of vegetation is there in particular city. So that we can take certain decision, in a city, let's say only 10% green space is there. So in this city, there is a probability that pollution will be more, and during the rainy season, the trees are not there. That's why the water will flow, the problem will create. So in this case, I want to know what's the percentage of vegetation. So I will download the satellite imagery or capture the data, remote sensing data, either through UAV or satellite imagery, and I will extract the vegetation, and I will know in which area I need to plant certain trees, or in which area I need to have certain green spaces or green parks. Then another problem is, I want to know the water bodies in the particular city. Last 10 years back, how many water bodies were there, now how many water bodies are there. So one of the problem occurs, like in you might have seen in the Bangalore, flooding comes very commonly. So what happened? People, there were lot of water bodies were there, lakes were there in the Bangalore city, and people, what they did, they filled the lake, they dried the lake, and they filled the sand, and then they made certain structure buildings. So now during the rainy season, what happens? The water losses there, and because of the flooding occurs. So this type of study can also be done. After before 20 years, how many water bodies were there, and now what is the status of those. So this type of studies can also be done, and based on that, the decision can be made how study had changed, and what can be what action can be taken. Then instead of manually digitizing thousands of features, AI model can extract them within minutes with high accuracy. So earlier, what used to happen, to prepare map or to extract the feature from the remote sensing data or satellite data, manual digitization, people used to do manually digitization. So it will take more time, and it is also the tedious process. So but using AIML algorithms, what we can do, we have different techniques are there. So using those techniques, we can extract the different features in very less time. Chain reduction is another area that helps identifying unauthorized construction, slum expansion, or shrinking green spaces. So I already discussed about this. We can take one image of T1 or T2, and we can see the how unauthorized construction has happened in particular area, how slum is expanded, or how green spaces or water bodies has shrinked in the particular city. Environmental modeling using AI such as LST downscaling, USA mapping, or pollution estimation directly support climate adaptation strategies. So LST downscaling means LST data, land surface temperature data, we get from Modis sensor is there, and from Modis satellite is there. Sensor name is Terra and Aqua. So from where when we get the data, we can get the data on daily basis, but its resolution is 1 kilometer, 1 kilometer by 1 kilometer spatial resolution. So we cannot analyze a particular city because its resolution is very coarse. So we can use deep learning algorithms to downscale that data. So downscaling means we can bring the resolution to the better. For example, we can make it to 250 meter or 100 meter or 30 meter. So this type of studies can also be done, and then these products can be used for the sustainable urban planning. So how we can analyze what was the LST in this year or this month and or this season, how LST is varying in last 10 years. So this type of studies can be done. Together, they help planners evaluate the present, monitor the trend, and forecast future scenarios. So, when we use AIML technique with remote sensing data, we can evaluate the present, ki what is happening in particular city in the present time, how the trend was there, like how LST trend was there in that particular city, or how the green space trend is there, it is reducing, or how much percentage there, and then we can forecast ki how the cities will grow in which direction. So these things can be done using the AI and ML techniques. This leads to more efficient governance, quicker policy responses, and improved long-term sustainability for city. So if we have this type of data, like we have present data, we have past data, and we can find the trend and monitor the trend, and using that trend, we can forecast scenarios. So based on those things, the policy makers or the government can take certain decisions. For example, let's say at particular area, green space is reduced, or like green space is reduced and pollution is more. So if we have the data, we can analyze, in last 10 years, green space was at let's say 50%, and now it is 20%, and air pollution was at certain level, and now it is increased to certain level. So we can say that there is a correlation between the green space and air pollution. So now the policy can be made that we can plant certain trees or make certain green parks, so that the pollution can be reduced, because from the previous data we analyze that there is a linkage between this green spaces and the pollution level. So this type of decision or this type of policy can be made. So if I talk about the remote sensing data landscape, so different type of data are there. If I talk about the based on the platform, it is satellite based data, UAV based data, or ground based measurement. Then if I talk about the sensor based, it's optical data in which there are multispectral and hyperspectral data, SAR data and LiDAR data. Uh, if I talk about the data characteristics, high dimensional data is there, temporal variability. There high dimensionality means, for example, in case of multispectral, there are 4 to 5 bands. There are certain in certain satellites, 10 bands are there, like Landsat 8 and 9. Then in case of hyperspectral data, there are huge number of bands are there, like 250 band, 500 band, 1000 bands are there. Then temporal variability, like we can get the data on daily basis. In case of MODIS, we can get the data on 5-day basis or 10-day basis. So this type of data characteristics is there in the remote sensing. So this complexity motivates adoption of learning based approaches. So the huge amount of data is available, but in order to process this data, we need certain algorithms or certain techniques that can extract certain information and handle this data, extract certain information, and within less amount of time. So that's why AI and ML techniques are required. So this is just a brush up the difference between AI, ML, and deep learning. So AI is the this broader set, and under that broader set it comes the machine learning. Uh, this includes SVM, random forest. So these comes under this machine learning. Then comes the artificial neural network, and then in artificial neural network it comes the deep learning. So deep learning, multi-layer neural network is there. You must have heard about the CNN and RNN. So here end-to-end learning is happening. So I will discuss later on what is the difference between machine learning and deep learning. So how it started? It started in 1950s, and how when a handful of pioneers from the nascent field of computer science, people started asking whether computer could be made to think. So they started like this: how can we make computer in such a way that they can think on certain problem and take a certain decision. So that another definition is to the effort to automate intellectual tasks normally performed by the human. So whatever human is performed, can the computer be made in such a way that they can take the decision like the human takes the decision. Machine learning arises from this question: could a computer learn on its own how to perform a specified task? So there is a difference between AI and ML. So AI means can machine take the decision, but in machine learning it says that machines are learning. There is a difference between learning and AI. So you can take a simple example. In many places, you might have seen that when you enter at certain place, the door automatically will open. Okay, so it is AI, it is not learning, because if you will put a box there, it will open the door. So here the machines are the decisions are being taken based on certain rules. For example, let's say a simple common example that all of you are using in day-to-day life, the email, your email. uh, so in your inbox, certain mails are there and certain mails go to the spam box. Okay, so in this email or spam filter problem, the algorithm that is being used is machine learning. Okay, so let's take the example. If we are not using machine learning, in that case we have to define certain rules. Rules means, like, let's say I will say, if I get the mail from abc123 at the rate gmail.com, then in that case it is a spam. Otherwise, it is not a spam. Now, what happens if the spammer will send the mail like this: abconetwo@gmail.com? In this case, it will not go to the spam, because in the rule we have mentioned abc123@gmail.com. So this is AI. This is not learning. But in case of learning, we have mentioned that ABC123. We have given the email, and we have said that this is a spam. So it will automatically go to the spam. So the difference is this: in case of AI, it is taking the decision based on certain rules. But in case of machine learning, by looking at the data, it is making its own rule. We know no need to provide any rule to the machine. It will automatically build those rules through by looking at the data. Okay, so very popular example was the spam filter of machine learning's popular example is the spam filter. So this is the basic difference between AI and machine learning. So in AI, what we have to do, we have to give rules and data, and based on that, the answers can be predicted. But in case of machine learning, we have to give the data and answers, and based on those data and answers, it will form the rules. And then once the rules are formed, step is called the learning. So once these rules are formed, then these rules can be utilized for the new data set or new data points, and using then prediction can be done. Uh, Now let's say about the deep learning. Deep learning, the machine learning, or why we are going for the deep learning algorithm. Machine learning algorithms are either not able to find the good accuracy, or not able to find a solution to the complex problems such as object recognition. So for that, we are going for the deep learning. So what are the deep learning? Deep neural networks do input to target mapping via deep sequence of simple data transformation or layers, and that these data transformation are learned by exposure to example. So you can see here there are different number of layers are there. This is input and this is output, and in between there are number of hidden layers. Okay, so in case of traditional neural networks, or we can say shallow neural networks, these number of hidden the input and output are common in both the deep learning and neural network. But these hidden layers are generally there is no hard and fast rule ki how many number of hidden layers should be there in the traditional neural network, or how many number of hidden layers should be there in the deep neural network. But if we analyze the traditional neural network, in those cases that these hidden layers were typically between 2 to 3 hidden layers. But in case of deep learning, these hidden layers are the huge number of hidden layers are there. Okay? One difference is this one. Another difference is this one: the feature extraction. In case of traditional artificial neural network, we have to give features. We have to extract certain feature. For example, what is the meaning of the feature? Let's say I want to extract buildings from satellite imagery, and from the I want to extract a building, so I have to give certain features, let's say I will give NDBI, Norway Defense Built Up Index. So this will help me to extract the buildings, because I am the expert of that domain. That's why I can provide that this feature will help to extract the buildings. And I will again I will another feature I can give key the size or the shape of building is the square or rectangular building is there. So these are the different type of features. that we have to provide in case of machine learning or a traditional artificial neural network. But in case of deep learning, we no need to provide any feature. It will, these are the images, it will automatically extract those features using these convolutional or pooling layers, and then these features will be passed to these neurons similar to this traditional neural network, and then decision can be taken. So this is how it works. The deep learning structure, how it is work. Input will be given, then certain layers will be there. It may be CNN layer or different layers are there. Then prediction will happen. It will predict certain thing, and then the using true target, it will check through the loss function ki how much loss has happened, and if it is in acceptable limit, then it will be will accept it. If it is not, then loss score will be calculated. Then using the optimizer, the weights of those layers will be updated in this way. So this is a iterative process. So deep learning has achieved the following breakthroughs, all in historical difficult areas such as near human level image classification, speech recognition, text to speech conversion, and many more. If we talk about the data dependency between deep learning and machine learning, so this graph shows the difference. This is the amount of data and this is the performance. So if data is less, in that case, this red color is the machine learning and blue color is the deep learning. So if data is less, in that case, the older machine learning algorithm or traditional machine learning algorithms will perform better. You can see. But if the data is huge, in that case, it suddenly the performance of deep learning algorithms suddenly increases. So this is the rule. Like if we have less amount of data, then use the traditional machine learning algorithm. Otherwise, if you have huge amount of data, then only you can use deep learning. Otherwise, it will not give the good accuracy. Hardware dependency, deep learning algorithms heavily dependent on high-end machines. GPUs are required to train the deep learning algorithms. But in case of traditional machine learning algorithms, you can use CPUs or low-end machines, so that can be run. Feature engineering is another thing that I already discussed. What happens? We have data, we have to extract certain feature, and then those features can be fed to the model. So in case of traditional machine learning, we have to extract those features. So that I discussed about the building extraction example. So in machine learning, we have to extract those features, and then those features can be provided to the model to predict or to give the output to desired output. But in case of deep learning, it will automatically extract it through certain layers like convolution layer, pooling layers. So using those things, it will automatically extract those features. So feature engineering is not required in case of machine learning. So by looking at this example, you can see in case of machine learning, this is input. Then we have to extract certain feature based on the certain expert in that domain will extract those feature, provide those feature, and then the feature can be provided, and then output will be obtained. But in case of deep learning, this is the input, and feature extraction and classification, it will be done automatically. It will automatically extract those feature. So you can see this example. These are the low level feature. Those are extracted initially through the initial layers, and then those features were combined into the subsequent layers. You can see using these features, it is automatically extracted. These are the eyes, and then using these features, it is making the by combining these features to making this face. If I talk about the execution time, the difference between machine learning and deep learning, deep learning algorithms usually take long time to train because huge amount of data is there and number of layers are also there. So that's why it will take more time. But in case of machine learning, it will take less time because less number of neurons or layers are there, and amount of data is also less. It is said that don't believe in short-term hype. Everybody is talking about the deep AI or deep learning is everything. It will solve everything, but it is not the case. You can see this study. An MIT study found that 95% of companies failed to achieve profit from their AI investment, highlighting issues with pilot project failures and poor strategy choice in implementation. So this happened. This is one study that was done by MIT. 95% of firms fail to profit from the investment. So what happened when certain hype comes in this any area? I'm not talking about only this area. So, but here we are talking about the AI. That's why I'm talking about the everybody is talking about the AI. So what happens? The companies will invest. कि AI will do this thing, AI will do this thing. But when the whatever they are expecting, if they are not getting, in that case, the investment will go down, and that particular technology will go down. It happened with AI 20, 30 years back also, when the this SVM came. At that time also it happened. So it may happen this time also. So the thing is, we cannot say कि each and everything will be done by AI. So when only required, in this particular problem AI will be required, and if this particular problem can be solved, then only we can go for the AI. Otherwise, by everybody's following, like we have to implement AI or we have to use AI in this area. Do not. I think you should not do like this. So now we come back to the machine learning or deep learning and remote sensing. So what we need? We need output y. We have x, is image feature, and this is the prediction function that we want. So during the learning phase, what we do, we give this image feature, we give this output, and we extract this, we obtain this feature. Okay, and this is obtained through the learning process. And then once we the model is learned or model is trained, at that time we will give this input feature x, and it will predict this y feature. So once it is trained, so what I want this type of output. This is my trained model. I will give this image, and this will give this particular output. This is urban area, and this is vegetation, and this is water. So this is how the deep learning model or any machine learning model will work. So if I talk about the training, how it is trained, initially images are given, then image features are extracted. In case of machine learning, we have to give the feature. In case of deep learning, it will automatically extract those features. Then training labels will be given, like if this image is there, so this particular image belongs to the urban area or vegetation area. In this way, we will train the model. Then once model is trained, so this trained model will be applied on the testing images. So again, during the testing time, if machine learning is there, we have to extract feature, and in case of deep learning, it will automatically extract those image feature, and then it will be passed to this trained model or learned model, and then the prediction will be done. So this is how this is the pipeline of machine learning or deep learning algorithms. So one case study, I'm talking about this, the difference between the machine learning and deep learning that we were discussing. So in this case study, what they did image classification was done, and using CNN, convolution neural network was applied, and they used Landsat 8 imagery. So you can see the results. These results are using the traditional artificial neural network or traditional machine learning, and these are the results obtained using deep learning algorithms or CNN algorithms. Okay, so what happened? They observed that the using the deep learning, the accuracy was 89.26%, and that was 11.52% higher than the traditional neural network. So what happens to in the traditional neural networks, when we pass this image to the model during the training or testing, what happens? It considers each pixel as a separate entity. There is no relationship between the neighborhood pixels. Okay, so it is not considering this special relationship. So each pixel is different. But in case of neural network, what happens? It considers certain patch, like 3 by 3 size, 3 by 3 pixels, total 9 pixels are there. This patch or this window will be considered as an input. So you can consider 3 by 3, 5 by 5, 7 by 7, and so on. So here they have considered this 5 by 5 patch. So in that case, what happened? They consider the special relationship, like a particular pixel is there, and nearby the relationship is there. What comes nearby this? For example, you can see if building is there, So nearby there will be a road because there will be connectivity. So that type of relationship will not be there in case of traditional machine learning because they are using a single pixel as an individual identity. But here they are considering the patch. Another example, this is image classification using neural networks. Here we consider only two classes, built up and non-built up. This is satellite imagery, and this is the expected output. So the Landsat 5 imagery of Bangalore city was taken, and there are total number six bands, and there are only two classes built up, one and zero means non-built up. That white color is built up and black color is non-built up. And the data was split into 60/40 ratio. This was the neural network that was used. These are the input layers. This is the input layer, and these are the neurons in input layer. And this is the output layer. These are the neurons in the output layer. So the number of neurons in the input layer are the or input features. So here six bands were there. That's why six neurons are there. And number of neurons in the output layer are the number of output classes. So here are only two classes are there, built up and non-built up. That's why two neurons are there. So in case of input and output, the how many neurons will be there, that is fixed. But in case of hidden layer, there is no hard and fast rule ki how many number of neurons should be there or how many number of hidden layers should be there in a neural network. There is no rule for that. That comes by experience, or we can try different combination. Then we can add or remove those neurons or layers. Okay. So here input layer has 6 nodes, and the one hidden layer was considered, and it has 14 nodes. And in this, the activation function that was used was ReLU, and in this output layer, the activation function was softmax, because softmax talks about the classification. That's why softmax was used. Then optimizer was Adam, and it was trained for the 3 epochs. Then using confusion matrix, we can analyze the accuracy of our model. So all of you know about this confusion matrix. So using confusion matrix, we can calculate different types of score. One is precision score. It is true positive divided by true positive plus false positive. Similarly, recall and F measure also can be calculated. So these are the result of confusion matrix. P score we got 81.5%, R score 83.8%, and F score was 82.6. Now this trained model was applied onto the Hyderabad image. The earlier image was this image was Bengaluru image. Then same model was applied onto the Hyderabad image. Then this is the output. This is Hyderabad image, and this is the extracted built-up area. Then same problem was solved using the deep learning algorithms or convolutional neural networks. So the same data set, Landsat 5 Bangalore imagery, 6 bands, and output is built up and non-built up. Here you can see we have taken 7x7 window. So again, there is no hard and fast rule to what should be the size of window. You can consider by trying different options. So we tried different options. We tried 3x3, then 5x5, then 7x7, then 11x11. And we found out that when we were using 7x7 window, we were getting very good results. Okay, so that's why you consider 7x7 window. And data was split into 60/40 ratio. And here the input layer contains 6 nodes, that is fixed. Output layer contains 2 nodes, that is fixed. And we had taken 3 layers in between, 3 done layers. One convolution layer with 32 nodes, and ReLU was used as an activation function. Then another convolution layer with 48 layer, and ReLU was used as activation function. Then dense layer, and it had 64 nodes, and ReLU was the activation function, and Adam was the optimizer that was used, and it was trained for 3 epochs. So these are the results. You can see accuracy is precision score is 93.1, R score 94.8, and F score is 93.9. So you can see earlier it was around P score 81.5%, that is now 93%. So you can see the accuracy was improved. Okay, so you can see the difference between machine learning or traditional machine learning and deep learning algorithms. So because they are giving more better accuracy, because they are more number of layers are there, so better they are learning the patterns in better way compared to the traditional one. They have a huge amount of data sets, so that's why also they are learning better. Another thing is feature engineering. Here what they are doing in case of machine learning, or traditional ANN, what they are doing, they are considering only single pixel as a single entity, but here they are considering a patch, so a special relationship was also considered. Then this trained model was applied to the Hyderabad image, and this was the output. So another case studies about the that we did was object-based approach for urban feature extraction from UAV data. So here we have used UAV data, and from this UAV data we extracted different features using object-based image analysis. So this was our study area. It is Lakshmi Narayan Institute of Technology in Nagpur, Maharashtra. This is the small part of the campus. So this is the overall methodology. The phase one is about the data preparation, the collection of the data, and marking of the GCBs. Then UV images were captured, and using those UV images, by after photogrammetry processing, the DSM was obtained. Then using the DSM, digital terrain model was obtained, and then by subtracting DSM and DTM, NDSM, normalized DSM was obtained. So what is the meaning of normal DSM is, we have DSM. DSM means digital surface model, that it will give the elevation of building tops also. So, and DTM is the bare earth model. If we remove these features like buildings and trees, if we remove, that model gives the digital terrain model, elevation of that bare earth model. So if we subtract this digital terrain model from digital surface model, it will give the NDSM. So it will give the height of those buildings. Okay. So this was used because many times it happens when we extract the features. Uh, so NDSM or height will be considered as a feature, and that can be utilized during the classification of the different features. So in the next phase was segmentation and feature extraction. So here input was ortho mosaic image, and NDSM was taken, and then multi-resolution segmentation was done, then feature extraction was done, and then after that different classification algorithms were applied, k-nearest neighbor, random forest, decision tree, and then comparative analysis was done. So these are the details of data acquisition phase. The average ground sampling distance, or we can say the size of one pixel, was around 4.5 centimeter on the ground. So very high resolution data. 569 images were captured. So these are the output. This is ortho corrected image or ortho mosaic, and this is the DSM that was obtained after photogrammetric processing of those UAV images. So this is phase two of segmentation and classification part. So here the thing is, there is no hard and fast tool key. During the segmentation process, there is an algorithm named multi-resolution segmentation algorithm. So in that algorithm, we have to provide different parameters. So parameters are scale, color, shape, and compactness. So in this, there is no hard and fast tool key how we choose these parameters. These are trial and error basis method. So we have to first select certain scales, at what scale we will start the segmentation. Then we have to give color and shape. So the value of color and shape will be equal to 1. The meaning of this is, for example, in this case, value of color is 0.1 and value of shape is 0.9. The meaning of this is I am giving higher weightage to the shape and lower weightage to the color. And then compactness, how compact are pixels we have to consider during the segmentation process. So this was the trial 3 that was considered. It was giving very good segmented out objects, and scale was 70, color was 0.8, and shape was 0.2, and compactness was 0.8. So this is we used e-cognition software is there. So in this, all the parameters you can provide. You can see we have given these layers, and we have given certain higher weightage to a DSM layer and DSM layer, and these are the values. Then once image is segmented, we have to provide the training sample. Okay. So in case of pixel based classification, what we do, we assign each pixel to certain class. This particular pixel belong to built up, this particular pixel belong to vegetation, and so on. But in object based in image analysis, what we do first segmentation. Like segmentation, the segmented objects are nothing but a collection of pixels. So first we do the segmentation, and these segmented objects are given as samples. So you can see this particular segment, whole segment was given to assigned to certain class. It is bare soil. Okay. So in this way, we have to give the sample. Different samples were given to different classes. Then during the classification, it is saying we have to select certain features. Which features we have to consider during the classification. So these all options are there in the software. These different features are there. You can select, like we have selected mean of these different layers, then standard deviation. In the geometry, we consider length by width ratio, area, word length, and many more. So you can choose different type of feature depending upon your requirement. Then these are the output. This is our orthomosaic image, and this is the output using the naive based classifier. So you can see in this area, this is a tree, but here what we got, these certain blue patches are there, and the blue patches are two-story building. Okay. And another one is this building. This building, this is a building, but what we got is this black color, then that is bitumen road. Okay. So some misclassification happened. So this may be due to this thing, like its color is like bitumen road, so that's why it may have misclassified it. Another misclassification in this was, this is the water tank. It is classified correctly, but this is single patch. This came from this two-story building. Okay. Then these are the output obtained using this SVM support vector machine. You can see again this building was classified as a bitumen road, and this tree was considered as a three-story building. And in this water tank, again this patch of two-story building came. Then these are the results obtained by dysentery classifier. So again, this building is considered classified as bitumen road. And here in the water body, this water tank, this bare soil patch came. This is the random forest. Again, this building was classified as bitumen road. This is correctly classified. Only one small misclassified object is there. Then this is key nearest neighbor. So this has correctly classified this as a three-story building, and this also classified this tree as a correctly as a vegetation or tree. This is also correctly classified as a water body. So by then considering the accuracies, or we did computer analysis, and we found out that key nearest neighbor was performing best in comparison to all other algorithms. So again, here I want to say that there is no hard and fast tool, or we cannot say that this particular algorithm is best in comparison to all other. It depends upon your study area, it depends upon what type of data you are using, or it depends also upon for what particular features you are extracting. So you when you do this type of thing, you can try all the algorithms, and which particular algorithm is giving best accuracy for your problem, that can be considered for the further analysis. Another case study that we did was about building footprint extraction using deep learning techniques, and in this we use satellite as well as remote UAV data sets. So this was our input data. This is what input we will give to the model, and this is the expected output that we want from the model. So here we considered two publicly available data set. One data set was containing 8716 images, and the size of the data set was 224 by 224. Cross 3 means RGB images. 3 bands are there. And another data set it was containing 2920 images, and its size was 256 by 256. Cross 3 means RGB images. So we combined both the data set, and then we used that data for the training. So initially, because both the data set have different dimensions, so during the pre-processing, what we did, we brought to the same dimension the 224 by 224, and then we converted the format to the PNG format. So these are our images and the corresponding output or labels. Then data splitting was done for the training and testing. So 80% was considered for training and 20% was considered for the testing purpose. Then we applied different data augmentation techniques. Data augmentation techniques are different techniques. The meaning of data augmentation is we are making data from the data. What happens in remote sensing domain? We generally don't find the labeled data. So, but in case of deep learning, we need huge amount of data. So using data augmentation technique, we can make data from data. The meaning of this is, let's say, we use these 4 data augmentation techniques. There are others also, but depending upon your application, you can choose from which data augmentation technique you can use, or that which data augmentation technique can be applied in your problem or your application. So, for example, we have used image rotation. So the meaning of image rotation is, like, I have one image. Let's say this image I have, and I will rotate it as a 180 degree. So this part will go here in this way. Similarly, in the same 180 degree, I will rotate this one. So what I have done, using this single image, I have made another image. Okay. Similarly, if I will do the noise injection, I will add certain noise in this. So from the same image, I have made another image. So if I have applied for these 4 techniques, so let's say I have 1000 images initially. Now after applying these 4 techniques, I have 4000 images. So you can see when we are applying the data augmentation, we are able to make huge amount of data. Let's say I have 10,000 images. So by after applying four data augmentation techniques, I can make it to the 40,000 images. So that will be a huge amount of data that can be used for training the deep learning algorithm. Okay. So next was the architecture that we used. Unit architecture was used in this. ResNet 34 encoder was used as the feature extractor. And we also tried different variations of ResNet 18, 34, 50, and so on. But we got the better results using the ResNet 34. And then learning rate was 0.005. Again, there is no hard and fast rule how we choose that particular learning rate. By trying different options, we found out that this particular learning rate was able to converge the model very fastly. That's why we applied this. Next, optimizer was used on Adam, and it was trained for 150 epochs. Then for accuracy check, we used mean IOU, intersection over union. So how it works? It works like this. It's another name is Jaccard index also. So let's say this type of problem, this type of output we got. This red color is the ground truth, and this green color is the extracted output. So this type, when we will overlay the extracted output or the predicted one onto the ground truth, if this type of scenario happens, then it is called a poor. In that case, the IOU value is around 0.4. And this type of scenario happens in that case, it is good. It is considered as a good, and IOU value is 0.73. And when this type of scenario happens, then it is considered as excellent, and IOU value is 0.92. So these are the results we obtained, and our IOU value was 0.91. That was near to the excellent one. These are the buildings that were extracted in this data set. And you can see in this particular image, there are no buildings. and our algorithm has also not detected any building. So many times when people consider the accuracy of their model, what they do, they consider only one feature. Like for example, in this case, only building. They don't consider that whether if building is not there, the algorithm should not detect it as a building. That part they don't consider. They only consider this thing. If building is there, is that detected or not? That's, but we have to consider both the cases. Another data set, SenseFair data set we used, and you can see these. This is the building and it is extracted properly. This is the building and it extracted properly. And in this image, buildings are not there, so it has not detected any building. This is another Zanzibar aerial data set. These are the buildings it has detected correctly, and in this buildings are not there, so it has not detected. Another case study that we did for building footprint extraction and chain reduction analysis in Kashi Vishwanath temple area. So, Kashi Vishwanath temple is a famous Hindu temple dedicated to Lord Shiva. It is located in Vishwanath Gully of Varanasi, Uttar Pradesh. Temple stands on the western bank of Holy River Ganga and is one of the 12 Jyotirlings, the holiest of Shiva temple. And geographic locations are these. Objective of this case study was the Kashi Vishwanath Corridor project was launched by Honorable Prime Minister of India in March 2019 with the aim of restoring the lost glory of the spiritual center. So, from the Kashi Vishwanath temple to Ghat, there was a not proper way was there because there are very narrow lanes were there. So people were facing problem. So that's why what they did, it 20 to 25 feet wide corridor was built, which connect Lalita Ghat on the Ganga to the Mandir Chowk in the temple premises. So due to this project, a lot of change happened from 2018 to December 2021. December 2021, Honorable Prime Minister inaugurated that. So the lot of buildings were dismantled. So this analysis we did. So objective of this study was to extract building footprints in this area and see the chain reduction happen from 2018 to December 2021. So image we use Google satellite imagery, and these are the RGB imagery, and the special resolution was 40 centimeter. And the model was trained on the images with labels as digital. So we manually digitized buildings for the training part. Then the model architecture was mass Gaussian was used, and its backbone or feature extractor was ResNet 50. Learning rate was this 0.00109664. Optimizer was Adam and it was trained for 11 epochs. So these are the result. This is the image of May 2018 before the announcement of this project, and these are the extracted building. Okay, so here the mandir is in this area. Then this is the when project started 2019. You can see the dismantling of the building has started in this area. Earlier it was not there. This is the image, and these are the extracted buildings. Then this is November 2019. Then you can see the construction has been started. This is October 2020, and this is March 2021. You can see the construction has been done. And this is December 2021 when the Honorable Prime Minister inaugurated this one. So these are the construction. This is the temple area. This one. This part is temple area. You can see a proper corridor is there from the temple to the ghat. So when we overlaid all these imagery and we analyzed the change reduction from 2018 to 2021, you can see from this map these all green color buildings are no change. That means they were present in 2018 and they are present on 2021 also. These red color buildings are those buildings which were dismantled during that time. And then these blue color buildings are those buildings which were reconstructed again. Okay, so you can see here in this image also, you can see earlier these were the buildings and these are dismantled from here, and then this new construction, these are new construction has happened. Okay, so this type of analysis can also be done. And then after analysis, these type of analysis, we can further prepare the map of the city, or we can take the decision, and authorities can make certain policies and decision can be taken. Another case study that we did for the Chandigarh area, deep learning based building extraction and change detection. So here we considered a small part of the Chandigarh area. So we considered three timeline imagery. First one is 2003, Iconos image was taken, and second one was 2012, Pleiades image was taken. Third one was 2021, Google imagery were used. The problem that we faced was because the 2021 image had 40 centimeter resolution. This 2012 image has 0.7 meter panchromatic and 2.8 meter multispectral image, and this Iconos imagery 2003 imagery had 1 meter panchromatic and 4 meter multispectral imagery. So spatial resolution was different. So we cannot apply same building footprint extraction algorithm to all the imagery. Either we have to train different models for all three, or we have to take same type, nearly similar resolution, spatial resolution of all three timelines. Okay, so in this study, what we did, uh, we used same building footprint extraction algorithm, and what we did, we brought this resolution of this 2003 and 2012 to the 40 centimeter resolution using deep learning algorithms. Some techniques are there, especially this super resolution techniques are there. Using those techniques, what we did, we first brought these resolution of these 2003 imagery and 2012 imagery to the 40 centimeter imagery, 2021 40 centimeter imagery. Okay, so building extraction model, we model was trained on 2021 this 40 centimeter imagery, and we 256 by 256, the whole image was divided into certain tiles, and the size of each tile was 256 by 256, and it was trained using mask RCNN using ResNet 50 as encoder. Learning rate was this, and it was optimizer was Adam, and it was trained for the 11 epochs. So then we during the analysis part or the accuracy assessment part, what we did, we divided our area into different types of building density area. So three type of building density area were considered: high density area, medium density, and low density. So this is the high density building area. So you can see the buildings are very close to each other. This is satellite imagery. These are the ground truth buildings, and these are the extracted buildings. And then the extracted and ground truth buildings were overlaid onto each other. You can see the green color buildings are true positive. That means building was there, and it was extracted as building using this model. True negatives are those the yellow color. That means building was not there and it was not detected by the model. So these are the correct cases. Then comes the false negative. False negative is this uh, light green color is there. False negative means building was not there, but it was detected as the uh, another case. Building was not there, but it was detected as building. And false positive means the building was present, but it is not detected as the buildings. So the accuracy that we achieved in this was 75.36% accuracy in the high density. That is considered as a very good in the high density area. Then these are the medium density building area, satellite imagery, then ground truth building, and these are the extracted buildings. And then when we overlaid it onto the ground truth, we overlaid the predicted building onto the ground truth building. The accuracy was 95.29%. And these are the low density building areas, satellite imagery, ground truth building, and these are the extracted buildings. And this is the predicted accuracy, 98.84% we got in the medium density, low density area. So once the model was trained onto this 2021 imagery, then we have to apply same model onto the 2012 and 2003. So in order to bring out the resolution of those 2003 and 2012 images to the as same as the 2021 imagery, what we use, super resolution technique we use, And for that, we used a architecture, GAN architecture, in which UNet was taken as the generator and VG16 as discriminator. And the model was trained using these parameters. Learning rate was this one, optimizer atom, and it was trained for 18 epochs. And this resolution of this is the input image, and this was the bench up with this so after super resolution the imagery we got. And once the 2003 and 2012 image was brought to the 0.4 meter resolution, then the same building footprint extraction algorithm was applied onto the all three images, 2003, 2012, and 2021. So you can see the extracted buildings in all three imageries. And then we analyze the change reduction. So this is the change reduction from 2003 to 2012. So here this yellow color buildings means no change. That means A32. That means those buildings were present in 2003 and are also present in 2012 also. And these purple color buildings are newly constructed building. That means they are not present in 2003 but were constructed in 2012. These are the newly constructed buildings, purple color. And these green color buildings are the dismantled building. So they are present in 2003 but are not there in the 2012. These are the area. These are. So then we analyze 2012 and 2021, and these are the buildings which were no change to one. That means present in the both the years. Purple color buildings are newly constructed, so you can see in this area new construction is happening. And then 20, that means they are dismantled. This area, the buildings are dismantled. And then we analyzed from 2003, 2012, and 2021. All 3 years were combined. You can see this color 321, A321, this color was no change or present in 2000 from 2003 to 2021. Then this yellow color 320 is somewhere here and in this part. They are present in 2003, 2012, but were dismantled in 2021. Then this black color, certain area here, here also, and at this point also. They were present in 2003, dismantled in 2012, and then again reconstructed in 2021. And these purple color building were not present 3 and then constructed in 2012 and then present also in the 2021. In this way we can analyze it. And you can see this red color building not present in 2003, came in 2012 and again dismantled in 2021, this area. So this area may be some certain temporary structure may be there. Initially it was not there, then temporary structure was made, and then again it was dismantled. So this type of analysis we can do using this deep learning or AI techniques. So the authorities can monitor in which area of the city development is happening, in what pattern the development is happening, and in which area in which area we can see some building removal is happening and what decision can be taken. This type of thing can be done using these techniques. Another building footprint extraction case study we did for using Cartosat imagery. So this Delhi area was taken, and here we used UNet architecture and VG16 as encoder, and it was trained for 100 epochs. Learning rate was 0.001. So this is the overview of the model. Cartosat multispectral and panchromatic imagery was there, and then we fused both the images, and building mass as a training level we digitized manually, and then model was trained. And once the model is trained, we given the input imagery, and it will extract the output. So this imagery not correctly shown, maybe some visualization problem. This is the image, and these are the testing label or ground truth, and these are the predicted one. So this is low density area, and we got the accuracy 89.56% in the Delhi area. Then the medium density area, this is the image test ground truth, and this is the extracted output 88.05%. And this is the high density area. This is the imagery ground truth and the extracted output. and accuracy was 85.67%. And this is the whole imagery. This is the subset you can see. Different areas of Delhi. This is the image and extracted output imagery and extracted buildings, imagery and extracted buildings. So in this way, different techniques can be, different algorithms can be applied, and buildings can be extracted. And then these extracted buildings can be used in different applications. Like authorities can take different type of decision, or you can see, you must have heard about this different government missions like Amrut government mission is there. So in that Amrut, there is a provision to prepare a master plan. So in that master plan, there are different layers are required, and those layers nowadays generally people extract manually, manual digitization by the manual digitization process, and that is very time consuming, a tedious task. So using these algorithms, you can automatically extract these layers, and these layers can be fed into that that part, and master plan can be formulated. Another a case study that we did, we developed a web-based tool in which what we did, we analyzed different cities of Uttarakhand. So here, what was the motive of this study? When we analyze the sprawl of the city, so by looking visually, we can say that in this particular direction development is happening, or in this particular area development is happening. But can we measure it quantitatively? So there are different special matrices are there that can be used to analyze the how sprawl is happening using quantitative techniques. So like let's say one technique is number of patches. So number of patches means ki when we classify the image, it will say ki these many number of patches are there in the particular city. So if more number of patches are there, that means we can conclude the development is happening in fragmented way. Because if whole city is in one patch, that means development is happening in continuous way. But if it is number of patches are more, that means the development is happening in fragmented way. So in this type of special matrices are there, different type of matrices are there. Using those matrices, we can analyze key what type of development is happening in particular city. So we consider different cities of Uttarakhand, class 1 cities. So this is the Dehradun city map. Extracted, built up. Built up is red color and yellow is non-built up. 91 image, 2001, 2011, and 2021. These are Roorkee map. 91, 2001, 2011, 2021. Similar, this is Rishikesh, Kashipur, Rudrapur, and this is Haldwani. This is Haridwar. This is Kotdwar, and this is the our web-based tool. In this web-based tool, what you have to do, you have to just provide this classified image, built up and non-built up type imagery. Here you can choose which metrics you want to use. So this special matrices are at different level. These are patch level, class level, and then landscape level. The meaning of this is uh, patch level means it will talk about different patches. Class level means it will talk about each class, like built up vegetation. It will talk about in this way. And then patch level, then landscape level means whole of study area. So you can select those special metrics, which type of metrics you want to analyze. Then you can upload your imagery, and then you can see different matrices are the values are displayed, and the plots can be seen. So you can see number of patches. So number of patches are increasing. That means the development is happening in a very fragmented way. You can see initially it was increasing, then it was constant, then again it is increasing. So that means development is happening in a fragmented way and nearby the cities. So these are the different matrices, like total areas will definitely increase during because development is happening. Patch density, then LPI, total age in this. So these are the different special matrices that will tell about the sprawl. So these earlier for this calculation of this matrices, there was no web-based tool available. Only some desktop-based softwares were available. But we in this study, what we did, we developed web-based tool, At the same time, we analyze different cities also, that whether they are giving the correct value or not. So this is how the different graphs can be plotted in a single way, from 91, 2001, 2000 to up to 2021 for a particular. This is total area. The matrix name is total area, and you can see for different cities how it is growing. Then another case study that we did, it is not directly linked to the sustainable urban planning, but it is related to the indoor thing. How the in many cases what happens, we need indoor 3D model of a particular building or particular area. Let's say one larger factory is there, and we need to take certain decision based on certain thing happened. So before something happen, we need to simulate on that 3D model. So how we can generate the 3D model of that indoor area. So in this area, what we in this study, what we did, we used a single panorama image, and using single panorama image, we estimated the 3D geometry of that particular building from the inside. Because in many applications that is required, like emergency response situation, if fire has happened, so what are the different paths that need to be taken. So this type of and another common example is this real estate. So you can make the 3D from the indoor, and then that can be used for the advertisement purpose. So 3D model can be reconstructed using photogrammetric techniques by capturing multiple imagery from different locations. But in this case study, what we did, we use only single imagery, and that was the panorama image. So uh, the purpose was to extract these corners. Okay, so if I am able to extract these corners, so by using mathematical transformation, I can reconstruct 3D. So how we extracted these corners? We used the ResNet architecture. ResNet 50 was the extracted uh, encoder or feature extractor. Then learning rate was 0.001. Adam optimizer was used, and it was trained for 400 epochs. And the dataset that we used was a Stanford 2D 3D plus Pano context is publicly available dataset. And these are our images. These are the input images, and these are the ground truth corners. You can see the bottom corner and top corner, like floor and ceiling corners. And these are the corners extracted using the existing algorithm, and these are the corners extracted using our predicted algorithm. And this is the accuracy assessment. The or proposed algorithm was able to this is the corner error, like how much error was obtained by comparing with the ground truth corner. So existing algorithm was giving around 1.47% error, and our algorithm was able to give 0.85% corner error. So these type of rooms are 8 corner panorama images. So 8 corner means 4 corner at the floor and 4 corner at the ceiling. So meaning of this is it is the rectangular type of room. And this is the 12 corner image. 12 corner, 6 corner at the floor and 6 corner at the top. So these are the ground truth corner. These are the corners extracted using existing algorithm. You can see the existing algorithm was not able to extract all the 12 corners. The existing algorithm was only able to extract these 8 corners instead of 12 corners, and our algorithm was able to extract all 12 corners, and the corner error was 0.47%. And this is a 16 corner image. So here these are the ground truth. Existing algorithm was able to extract only these 8 corners, and our algorithm was able to extract all 16 corner, and the accuracy the corner was 1.31%. And these are the reconstructed indoor models. 8 corner panorama, it is cuboid shaped room layout, and this is 12 corner, this is L shaped room, and this is 16 corner, this is T shaped room. But here we use single image, and then one assumption was there that these all buildings are of regular type. That means the building floor and walls are will intersect at perpendicularly, will be perpendicular to each other. So this type of assumptions are taken, but in the real world this may not happen. So in the future we can take these consideration and improve our algorithm. So how these different works that I've shown, building footprint extraction and green space extraction, all chain reduction, how they are linked to the sustainable urban planning. So building footprint extraction can be used for infrastructure monitoring, growth monitoring, resilience of city, how the development is happening, and which area it should not happen. This type of decision can be take. So how this is how building footprint work can be utilized there. Green spaces work that can be utilized, like heat mitigation, livability, clean up, in which area the pollution will be more because of the less green space. So that type of decision can be taken. UV based object extraction that we did. So micro level planning. So nowadays you might have seen that in AMRUT 2.0 scheme, government has mandated that the mapping will be done using UAV. So that type of that type of work can be taken in that area. Building change detection can be used in this compliance, heritage, disaster management, before and after, how things are there. Urban sprawl detection, then land management, master planning. So master plan formally, then people, when will they will plan a master plan, then they can consider that in this particular area urban sprawl is happening and what was the driving factor. So this type of this in this way, these different type of case study can be utilized in urban planning. Then role of these studies in the national mission, how we can use different type of these case study or AI, ML, and remote sensing in a national mission. So Amrut mission is there. The building footprint from satellite or imagery, for they can be used for master plan analysis. The green cover mapping can be used for planning of parks, open spaces. In a smart city mission, high resolution building and road networks are required to take the decisions. So that can also be utilized. Change direction from temporal image. So in smart city, we need to monitor the new construction or illegal encroachment are also need to be analyzed. So those can be utilized there. Then other national initiative like Pradhan Mantri Awas Yojana, so identifying where is the vacant land. So we can get the satellite imagery or remote sensing imagery. Then we can extract features like where are the vacant land parcels, and then that vacant land parcel can be utilized for the housing part. Then National Urban Digital Mission, in this 3D models can be developed, and those 3D models can be utilized for the digital twins. Then what are the key challenges? So there are certain key challenges are also there. So first one is data related key challenges. So scarcity of label training data. So in remote sensing, what happens, we don't find the training label training data. So this is one of the common challenge in the remote sensing, the processing using AI and ML for remote sensing data. Sensor heterogeneity, different type of sensors are there. Optical is there, SAR, lidar, UAV. So they have different type of sensors are there. Spatial resolution is different. Noise characteristic is there. Temporal resolution is there. So these type of so these different for different type of sensor, different type of data, we have to develop different type of models. So this is another challenge. Can we make a model, and can we consider all the type of data in a single model? So this is another challenge. Temporal dynamics, land surface changes seasonally and annually. So you might have seen that in a particular city at within 6 months, things are changing, like building is there, or if river is there, it was like changed, or it is now it is not there because of the this dry thing. So this type of temporal dynamics happens in the areas also. Data quality and accessibility, cloud cover is a very common problem. You cannot get the optical data during that rainy season. Atmosphere effect, varying data licensing restrict the model training and validation. So many times it happens we cannot get data because of the license restriction in the different because of the different country issues. So this is another problem. Model related challenge, computational cost. But to train the deep neural network, we need huge computing power, GPU or TPU. So and that those computational power require huge amount of energy. So that is another problem. Generalization and transferability, model trained on one region or sensor often perform poorly when applied to elsewhere without retaining or domain adaptation. So what happened, like I have trained the model on the Delhi area, so I cannot apply the same model onto the Dehradun area or Gandhinagar area because of the region different region had different types of characteristics. So this is that is also another problem. Can we make a model in such a way that can be applied to all type of similar type of the city? Then interpretability and trust and ethics. So bias and fairness, uneven geographical representation in training data set. What happens, like for example, I want to develop a building footprint extraction model for whole of India, and I have considered training levels only from certain levels from the Delhi. I have not considered from the Bhubaneswar. So this will be the uneven geographic representation. I have not considered the training labels from the Bhubaneswar area. So this is the bias. Privacy. High resolution imagery can capture sensitive locations. So many times it happens that we have captured the imagery from the UAV, and it may capture the sensitive location or personal information of the people. So that is also a challenge in this area. Future directions. What are the future directions in which we can look? Multi-model models, develop models which combine different type of sensor data like optical, SAR, lidar, or socio-economic data. Also we can develop this type of model that can consider different types of data. Develop models which can process different spatial or temporal or resolution data. Like we faced this type of problem in the Chandigarh case study area, where we had different type of spatial resolution. So we had to convert that first into the same resolution, and then we applied the same model. So can we develop that type of model which can consider different type of resolution data and process its own? Then another agent real-time processing. Can we develop model which can process data on onboarding, like on satellite or UAV on body on board? They can process the data, and they can provide the near real-time information. Interpretable AI. Nowadays, the deep learning models are black box model. We are giving some input and it is giving output. How or why this output was obtained, that is not clear. So, but nowadays the explainable AI is there. So, using explainable AI, we can consider that area, how that particular area, how that particular output, how we obtained, that can be also the future direction. Super resolution. In the urban area, this is very common problem. In urban areas, to map, we need high resolution data, but high resolution data are either not available or available at a huge cost. So can we develop certain model that can convert the low resolution or post resolution data into the high resolution data? So that is also another direction that we can look. So thank you. That's it from my side.
Thank you, sir. Audience, if you have any question, please ask or write in the chat box. Participants, if you have any question related to this content, please ask. You may raise your hand also. Sir, our question is given in the chat box.
Okay.
Was a separate data set used for validation or testing? If so, how the data set should be splitted? They are asking about the ratio, how to decide.
Okay. So the question was a separate data set used for validation testing, and if so, how was it? Yeah, okay. So there are two things. There are three things: training, validation, and test. Okay. So what happens when we have a data set? We divide the data set into three parts. Like let's say we have taken 60% for training, 20% for validation, and 20% for testing. So different set are used. So 60% was used for training, and then once the model is trained, we use that 20% data for validation. So in the validation stage, what they do, model was trained, but in order to fine tune the model further for better results, we use that 20% data set or validation data set. And then once the fine tuning is completed, then we use the test data set for or prediction, or whether it is giving the correct prediction or not.
Okay. Thank you, sir. Hopefully the answer is given to the audience. Any other question if somebody wants to? Okay, sir. I need to ask something.
Yes, yes.
Uh, Encroachment. This is the, very typical problem
Yes,
of
yes.
India,
Yeah.
uh, because extending the boundary to the road.
Yes.
So it is really the way the India is working over, or the you are working over here. So is it really possible to find how many feet or meters somebody has extended the boundary?
Yes, sir. Uh, Actually, the thing is, for encroachment analysis, we need very, very high resolution data. Satellite imagery is there. So what we can do, we can, for example, take the previous year data set or old data set, and we can extract the, like, let's say, building or roads, and then we can use the present data, and we can superimpose both the data sets, and then we can see how much extraction that encroachment has been done. Another way is, like, many times what happens, in 2D, we cannot see the exact encroachment. So for that we need to go for the 3D modeling. So for that UV comes in the picture, UV and ground truth data, and then we can make the 3D model of the area, and we can see how much encroachment can be done. So that if it is georeferenced, we can definitely measure how much encroachment has been done.
Okay. Thank you, sir.
Okay.
Uh, Audience, any more question? Hopefully, all answers are already given. Still, okay. If not, then we will go for the next part. Uh, Now I invite Professor Mr. Sushil Chaturvedi to propose vote of thanks.
Yeah, me, sir, I'm audible.
Yes, sir.
Yeah, yeah. Okay. So, good afternoon, everyone. It is my privilege to propose the vote of thanks for this highly insightful session. On behalf of the organizing committee, I, Sushil Kumar Chaturvedi, extend our sincere gratitude to our esteemed speaker, Dr. Suren Kumar Sharma from Indian Institute of Remote Sensing, Dehradun. Dr. Suren, your engaging presentation on AIML for sustainable urban planning was extremely relevant and added immense practical value to our FDP. It perfectly reflected the core theme of FDP. The knowledge shared on AIML learning for sustainable urban planning will inspire our participants in their research and development activities in the domain of urban planning. His deep insight into ML, AIML, and remote sensing technologies, their applications in urban planning, and their potential to build sustainable, resilient, and human-centric cities of the future. The clarity of his explanation and the practical example shared have offered valuable knowledge to all participants. Finally, a big thank you to all the participants for your active presence and thoughtful interaction. Thank you once again, Dr. Shri.
Thank you, sir. Suren sir, might there is some problem with audio, but
Yes, sir.
I must say it was really a wonderful session here, and the way you shown the picture how India is actually working over these things, and how AI is actually captured, and how it is being used by each and everyone. So that's really a big thanks.
Thank you so much, sir.
Thank
Thank
you.
you.
Thank you.
Thank you.
Thank you, Suren sir.
Thank you. Thank you. Thank you.
So,
Okay,
Sir,
I
Munish
think
sir has joined our meeting.
yeah. Okay, so Munish sir, namaskar.
नमस्कार सर जी कैसे
Okay,
हैं
sir,
सर
let's बस बढ़िया सर और I think you have already joined so we should start.
या श्योर
Okay. Okay, audience, good afternoon once again, and now we'll proceed for the next session. I invite Dr. Munish Singh, Associate Professor, CSC, NIT New Delhi, to deliver his talk on IoT in agriculture. Here, I would like to introduce Dr. Singh to our audience. Dr. Munish Singh is an assistant professor at Department of Computer Science at PDPM IEEE Jabalpur, India. Prior to this,
नो सर प्रायर
prior, sir, yes. Prior to this, he was an assistant professor at Indian Institute of Information Technology, Design and Manufacturing, uh, Kochipuram, Chennai. He has industrial experience with the Honeywell Technology Solution Lab, Bangalore, India. He obtained his PhD degree in computer science and engineering from National Institute of Technology, Rourkela, India. His current research interest includes IoT, machine learning, cybersecurity issues in IoT, cloud computing, wireless sensors, SDN, connected cars, and CPS. He has published over 30 articles in peer-reviewed journals and conferences to international repute journals. He serves as a reviewer of many peer-reviewed journals, including IEEE Transactions, Journals of Elsewhere, and Springer. He has also served as a technical program co-chair and technical program committee member of several conferences of international repute. He is senior member of IEEE. Now it's time to hear from Speaker Dr. Singh. Sir, the spotlight is yours.
Yeah, thank you, sir, for giving my intro. So, first of all, I thank the organizers for inviting me for the today's session. And I also welcome all the participants who have joined across India for this particular workshop. So please give me a second. I'll just share my screen.
Yes, sir.
Actually, my screen is visible.
Yes, sir, it is.
Okay, so my not on the green picture, but it's similar to that. It's for the aquaculture. So we basically develop the solutions for improvising the freshwater aquaculture, which is basically operated in our India as manual ways, and there can be a certain improvements we can bring it out through certain automations through IoT and machine learning techniques. So my topic of the today's session is development of freshwater pearl culture unit based on IoT and machine learning techniques. This research basically we have done under the sponsorship from the DST seed. So this is what my initial project which I received when I started my career uh, to the central government institutions. So I'll give you the brief about how the freshwater aquaculture is basically done in India and how we can improve that to make it a more profitable venture for the farmers who are suffering from the various crop losses. So this project is basically initiated in 2019 and we have completed that in 2023 with the all desired goal within this project. And we have actually demonstrated practically how the freshwater pearl culture can be harvested in a small aquarium tanks. So our journey begin with a very basic learning how basically the aquaculture basically works in India. And we have done a extensive survey on this, and we also took a training from the CIFA, the one of the institute in our India, which gives the training on freshwater aquaculture. It is located in Bhubaneswar, Central Institute of Fishery Institute, which is one of the kind in our India that gives the training on pearl farming as well as shrimp farming and various kinds of aquaculture related uh, trainings. So that is what our beginning was with CIFA. Actually, I was not very much well aware about how the water aquacultures can be done. And only the coastal region of the India, there the people are doing, and more of them are doing it basically through manual labor. So this is what we have observed, like what is the gap where we can contribute it for the better productions and the quality of productions. So let's begin with this. What is the common notion that water is a free commodity is no longer a reality? If we can see the current global warming and so many changes in the weather patterns, as well as our atmosphere is now polluting too much. And too many things are happening together, which is basically deteriorating the water quality in the certain regions. If I can specifically say that underground water is now no more applicable, like you can directly consume it. You have to filter it and then only you can use it. So in India, we have seen the fresh waters are not available as freely as what we have seen in the last 20 or 30 years back. So international water management institutions reveal that by 2050, nearly one third of world populations would live in the region of serve water scarcity. So many countries, if we can see Sudan and the Arabian countries, they are severely affected because they were not having the free water, or what I can say fresh water for their daily use or for their lives. They are basically converting the ocean water into the fresh water, or either they are buying it from the other nations. Those are very rich in the water bodies. So India is also one of the player where we are selling our Narmada River water to the Dubai, Arabian countries. So by 2050, India has to produce about 17.5 billion tons of fish per year, and 80% of total production must come from the aquaculture. So we are very much rely on the coastal region where we can have a sufficient water bodies. Even we have a fresh water bodies sufficient to grow the various other aquacultures. So fish in which we are dominating, and we are also exporting so many variety of fishes to the different countries. But we are lacking in the profitable aquacultures, which basically required the specific requirements. I must say that pearl farming, very initial years, I must say ancient India, the pearl production in India was the dominating. India is dominating in that, and China and Japan, they were not near to Indian production. And suddenly we have just lost this race, and now the China and Japan is basically the largest producer of the freshwater pearl. So you might have heard about the pearl is basically you can found in oceanic beds in the within the oysters, but it is not the real truth. We also have the pearl in the fresh waters. We can actually grow them in a fresh water, much larger than what you can found in the oceanic bed. But for that we required the technology, and we are not as much technologically advanced as what we see China and Japan. They have these days they are producing the gem quality pearl, which is basically a golden luster pearl, are also produced by the Japan and China. So they are currently the largest producer of the freshwater pearl, and they are also the largest exporter. And we are actually the importing these pearl from the China and Japan for our pharmaceutical needs, cosmetic industries, and various other industries where we basically need this pearl. So the need of judicious management of these natural resources and development of strategies so that we can basically utilize the water more efficiently, and we can reuse the water to multiple times. That is what we have come up with a solution where we can preserve the water and we can reuse the same water again and again. So we have developed the RAS systems, recirculative aquaculture system, where we are using the same water and we clean it through the biofilters and then reusing that same water for production. This particular experiment, we did it with the aquarium tanks. We have taken some aquarium tanks and placed them in such a way that the harvesting tank water we can pass on to the below tank that is fitted with the biofilters. And the water once cleaned, then we reuse the same water into the same harvesting tank. And that's how we are managing our water uh, wastage. So if you can see the current trend, the production risk is at peak if you can see the water, underground waters in our India is not that much good, and it's now getting saline kind of water. It's too much excessive heavy metals are found in the water. They are neither be the good for the aquaculture, neither they are good for the human beings to drink directly. So adverse environmental conditions and industrializations, and we are keep on polluting our mother nature, and that is how we are now coming near to a kind of devastations and the kind of hazard we have started seeing in various scenarios. So in India, if we can see, the most of the aquaculture production is in the fish farming and the shrimp farming, different kinds of farming, which is more relative to the fish. And we are barely looking towards the profitable aquacultures, in which the pearl farming is one. And currently, if you can see, seaweed farming is also one of the profitable venture that farmers can choose and basically generate their alternate source of income. And they barely required large areas, so you can even do that kind of production in your home or in a small pond that doesn't require a big land to grow. So we have done an extensive survey on this, how the pearl is getting produced and how it marketed into the Indian markets, and what will be the revenue that we can generate out of the pearl productions. So I'll take you to the entire steps, how we have begun our journey and how we really creating that environment so that the pearl production can also be happened in the smaller tanks. So water quality, like in land-based agriculture, if you can see, we are very much familiar what we can grow and which particular season is better for the particular crop. We are very much familiar with the land-based farming, but we are very much little know about how the water quality can severely impact the productions in the aquaculture. So water quality is basically play a very important role in maintaining the quantum of aquatic productions. And we are just looking at few things in the water quality parameters, and we are starting the kind of businesses related to the aquaculture. And most of the farmers are getting failed because they are not well equipped with the skill that required to managing the water quality. So that is what one of the large barrier that is restricting the farmers to get the better productions, or sometimes the farmers are failed to basically do the water quality management or monitoring. So they are also failed in such aquaculture businesses. So it determines the ultimate success and failure of the aquaculture operation, how better you can know the skills related to water management and water quality parameters. So farmer must measure, record, monitor, and managing water quality parameter all through the growing season. So that is why there is production risk if farmer is not well equipped with the skills that is required for the pearl production. So our motivation here is like to make platform ready for the farmers so that they can reap good revenue out of the aquaculture if they failed in the regular farming, that is land-based farming. So India has a 2.36 million hectares and tanks, which offers the immense opportunity for agriculture businesses. So apples in India. So it's a big number. And freshwater per cultivation is the most profitable business in current scenario because it has a end product has a significant market reach, limit not limiting to this one or two. If you can see the medical, we have Shelcal tablet, which is basically calcium carbonate tablet, calcium tablet that we give to the patients Same way, the cosmetic industry, various creams that you see, facial creams and body moisturizers, and many other items, the particular pearl has a significant uh, applications. So the major roadblock here is the lack of technological intervention is the primary cause of poor production, because we are doing the regular farming, and even though if we are doing the manual farming in aquaculture businesses, we are not very much know about what water parameters significantly affect the production quality. So that is what kind of knowledge is required to be delivered to the farmers, or either we can make some systems that could provide the proper monitoring and management for the water quality parameters. So by changing a small water parameters could change the quality of the pearl. If you can see, there can be a different varieties of pearl you can produce from the same oyster or the same mussels that you use for the uh, in the harvesting tank. So magnesium in the water, if you can increase, or alkalinity in the water will increase or decrease, will actually affect the luster quality of the pearl. So baseline data, basically, we took the training before we execute our project. We took the training from the CIFA, Bhubaneswar. It's the Central Institute of Freshwater Aquaculture located in Bhubaneswar. It is only a one institute that gives the training on pearl farming, and it is the only institute also, I can say. So we took the training from this institute before we start executing our prototype platform using aquarium tanks to grow pearl inside the aquarium tank. So the ideal parameters that we understood from this training is like pH should be 7 to 8 ppm. Mostly alkaline water is better for the pearl productions. And dissolved oxygen should be kept 5 ppm, which is ideal for the species that we are using for the pearl farming. And in our India, 52 river basin, basically 52 species are there, they can produce the pearl. And the most effective one is the Lamadin marginalis. This particular species we have used for our pearl production, and it is easily available. If you can see, we ordered it from the farmers, and each of this cost around 8 rupees to 20 rupees, depending on the size, depending on the uh, particular age of the species. Okay, so different farmers will rate for different, and we get this rate from the India Mart, is a business to business or business to client connective application. Basically a website from where we locate who all the farmers are dealing in the particular kind of species. So we ordered this species basically from the farmers directly, and 500 mussels at a time we have ordered. And with that 500 species, we have started our experimentation. And it is not like so easy that we can directly get it from the farmer and put it them into the tank, then it will basically start producing the pearl. If I wanted to grow the pearl, particular whether it can survive in my water bodies or not. So this baseline data we actually gave us the basic training, how we basically begin with the baseline data. And first and foremost important thing, if you want to grow a pearl in this particular kind of species, then you must follow the particular water parameters. So alkaline calcium carbonate 100 ppm, hardness of the water should be 100 ppm. Hardness should be 60 ppm. Temperature ideal for the These mussels are 25 to 30 centigrades. And the food, this particular algae is basically planktonic algae. It's a green algae. And blue algae is also ideal for this particular species. So it is easily available. And the ideal size that is for this particular pearl growing is 35 to 50 gram should be the weight, and size should be 7 to 8 centimeter is ideal for the pearl production. So with this data and the basic training for surgery as well as creating this particular pearl water environment, we took this training, and then we come up with our IoT solutions, how we can basically deal with the manual skill based training to be transformed into the IoT automations. So the skills that is required for pearl production is very, very stringent. If I can say, if you are missing out the water parameter management properly, then there can be various problems that you can see in the mussels. They can start dying into the tank, and they can come out from the bottom to the top as soon as they die, and their um, muscles will get open. So that's how we can know that they are dying because of the inadequate water quality parameters. So water quality parameter is must, and the management of these water quality parameters is also very, very important. So we come up with the solution where we kept our design framework to be in three different phases. Like we have come up with the physical design where we can actually have the sensors and actuators. Those are playing an important role for the measurement and monitoring the water parameters. And the actuators are playing a role to managing that water quality parameters. So by taking out the water from the harvesting tank and putting them into the biofilters to clean the water and maintain the basic water parameters. So in aquaculture, we basically required to managing the dissolved oxygen parameter, very, very important. And the ammonia concentration should not get rise because it directly relate to the pH of the water. So if ammonia is getting increased into the water, then it consumes the dissolved oxygen will start depleting, and the pH value of the water will get increased. So we have to ultimately managing the ammonia concentration. If we could able to managing the ammonia concentration and maintaining the dissolved oxygen parameters to 5 ppm, our pond will have the habitable water environment that is basically ideal for the mussels. So we have used basically the control actuators. If you can able to see here, I think it may be not quite visible properly, but if I can zoom it that much. So the control actuator that we use is pump, oxygen pump, biofilters, and solenoid valves, and a particular edge device. So this device is basically connected with the actuators, and the sensor modules we have used that pH sensor, dissolved oxygen, TDS, and temperature sensor. So these are the sensors that we used for monitoring the water parameters and controlling the water parameters. These actuators are in action. And this whole data, we are actually dumping it to the fog node. So in a cloud environment, we cannot directly rely on it because there can be a connectivity issue. Sometime internet is not available. Sometime data is not delivered it on time. The processing will also take time. So we have directly rely on the fog node. In the fog node, we are running our web server. In this web server, we are loading all the data, performing the basic data analytics to figure out whether the water parameter is severely changed. Then we can start operating the actuators. So water management and control will be taken care by the control actuators. And the decisions is basically driven through the basic machine learning algorithms They are analyzing the data, and whenever there is a requirement for operating these certain actuators, we are driving that particular actuators based on the requirements. And we are maintaining a database where we are keep on pumping the data. The historical data is maintained into the one database. Another database we are also running where we can upload the latest data. So our algorithm and the web server is using the data from the database, and the algorithm, this dashboard, IoT dashboard that we have prepared will basically visualize the current data, sensor basically monitoring the water parameters and visualizing on this dashboard. So we are running this particular IoT dashboard in two different places, one at the AWS cloud, another we are running it the small IoT device, which is uh, basically supporting the AI computations much faster than what we have at the edge node. So we are running our algorithm in this particular small device. We are connected with internet through this gateway to the AWS cloud. And we are running there also an algorithm is to visualize the more historical data that what we collected in the database. So if we want to make managing all the water parameters and historical evidence, if we want to figure out in certain case, let's say sensor is performing right or wrong, okay, fault diagnosis in the sensors and various other kinds of analysis, we are actually performing at the cloud rather than relying on the simple fog node. This particular place, we are keeping only the management module. If we want to make a quick management requirements comes, we can take the action immediately rather than relying on the cloud to get the particular response. So this is how we
Sir,
have designed our physical design. Yes.
sir, your PPT is not visible. Is
Oh,
it
it's not.
intentionally or
No, 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 it's visible. No? Okay, okay. Let me
okay?
check.
Not at audience side, that's why.
Okay, okay, okay. Just a second. Let me switch network. Is it visible?
Not now, sir.
Is it now visible?
Not yet, sir.
Okay. Let me turn off just a second. I think now is it visible?
No, sir.
So should I reconnect?
Yes, sir, that should be better.
I think let me check. Sir, is it visible?
Yes, sir. Now clearly.
Okay, so our IoT design framework is basically divided in three different designs. So physical design, specifically comprising the actuators and sensors. Network design, we have basically creating the networks between the gateways and the fog node that we have created, which is basically act like a cloud to our local networks, private network. And we are running our basic algorithm in this machine learning algorithm and the data visualization web server. So we are basically maintaining a two databases. One database is keep on recording the all data. Another database is keep on recording the recent data received from the sensors, and it is going to be get visualized on the IoT dashboard. And same way, we are also maintaining cloud databases where we are actually visualizing our data to a massive scale, because all the data we are not able to process it. So all the historical data, let's say for a month or 2 month data, we can process it and find out whether the sensor values are getting drifted from its originally when we have started recording the data from the sensor. So we can do the fault diagnosis at the cloud. So we are running one probabilistic neural networks at the cloud to monitor the historical data and identifying whether there can be any change in the data or not. So if any sensor value is drifting from its original scale, let's say if any sensor, if we can look at, there can be a tolerant limit. So if there is any tolerant limit crossing by any sensor value, we can simply raise an alarm. Either we can go with a recalibration to the sensor value, or either we can replace the sensor. So we want to make the system as much as cheaper for the farmers, because they cannot go for direct changing the expensive sensors like dissolved oxygen sensor costing around 20 to 30,000. So that is ultimately a huge cost for the farmers to bear. So we brought our data analytics, relational data analytics into the action. And we are considering only the sensors which are more robust. And by analyzing the historical data, we are minimizing the requirement for the sensors data. So once we have made the relationship with the particular water parameters, we no more required for the sensing. We can still predict and forecast the water parameter change by simply knowing what will be the change in the TDS value or the temperature, pH values, or the temperature as the catalyst for this whole reaction. So that's how we brought our basic design. So in physical system, we have used the temperature sensor, we have used the pH sensor, and we have used the dissolved oxygen sensors for monitoring the initial stage. Whatever be the change in the water parameter, dissolved oxygen will change. So our basic requirement here is to maintain the dissolved oxygen to 5 ppm, and dissolved oxygen change is basically very lethal for the living organism that we are using for the pearl farming. So dissolved oxygen, if we maintain to 5 ppm, then we can able to maintain the adequate water quality parameters for the particular mussels. And the water electrical conductivity sensors we have also used to monitor the TDS change into the water. So how much ammonia concentration is getting introduced in the water. So whatever the living organism that we are using for this particular aquaculture is basically eating the plankton algae and excreting the ammonia into the water. Basically, excretion will basically introducing the ammonia into the water, and that is directly relative to the change in the water parameters, pH, and dissolved oxygen parameters. So we have to basically minimize the ammonia concentration in water, and for that we have created the RAS system, using our actuators. So in the actuator side, we have used water pump, we have used aerator. So we are diffusing the air into the water so that the oxygen concentration can be maintained to 5 ppm. We have also designed a feeder. So plankton algae as a powder, if we can mix into the water, we can make it soluble into the water, and then we can pump it whenever we require to feed the mussels. Then we have used a biofilters. We kept it just below to the aquarium harvesting tank so that the water came out from the harvesting tank will pass on to this biofilter, and the clean water we can resubmit into the same harvesting tank. Then we use a water heater because in the winter season, the mussels will require the adequate temperature 25 to 30 centigrade. So to maintain that water temperature, we also use a water heater. So in summer, there cannot be any problem. But in the winter season, the northern region of the India will have the temperature to be 5 to 6 centigrade. So how we can maintain that temperature so that the mussels will not get affected with the change in water change in the temperature. So 1 degree change is very lethal for the living organism in the aquacultures. So if you can change the water and there's some hot water to the cold water, then also it can affect to the aquatic animal. So your mussels will able to tolerate up to a few degree of change in temperature. If there can be a 2 degree or 3 degree change, then few mussels may not survive to that much temperature change. Even some fishes, fish farming, if you are using 1 degree change is very lethal. So you have to understand what will be the required parameters to be maintained for the particular type of species. And that is what we have to understand, what is the biological structure and what is the required parameters on which we can basically grow this particular crop. Okay, so solenoid valves we have used because we want to control the input and output of the water that we are taking it from harvesting tank, when we have to stop and when we have to resubmit the water into the same tank. So this is a small BeagleBone board that we have used. BeagleBone is basically a single board computer. So this we have used it as a edge device on which we have various general purpose input output port. So we have integrated all these sensors because it has so many GPIO ports and it has an onboard eMMC. So we don't require any SD card to connect. We directly store our data, process our data to the edge device because it supports 2 GB of eMMC. So flash memory is available on the board itself. And it is faster comparing to the Raspberry Pi board. So we have used this board, and it has a it has a only 12 bits ADC. So some sensors that we are using is basically analog sensors. So pH sensor, dissolved oxygen sensor, TDS sensors, they are analog sensor. So we have connected with I2C port 116-bit ADC. It is a differential ADC. So we can basically create a higher resolution. The small change in the pH value we can also monitor. So 16-bit ADC we have used. If you want more precise change, you can even go ahead with the higher bit ADCs. So 16-bit ADC, we feel that it is sufficient for monitoring the change into the pH or any water parameters. A small change can also be visible. We have created one drop counter for this particular testing scenario because we want to control the reagents to monitor what will be the ammonia. So ammonia sensor is very costly. Optical sensor is very costly. So we have designed our own sensor system to monitor the ammonia concentration in the water. So we take a small sample of water from the harvesting tank automatically, and that comes to the small conical funnel. and we mix the reagent with the burette. So burates basically we use in a chemistry experiment to control the regulated amount of drop of the reagent to find out what will be the calorimetric based experiments to figure out what color is emerge out when we add the water with the reagent. And based on that calorimetric representation, we can identify what will be the change in water parameters, like how much pH change. So that kind of sensor we have designed, I will show you. We have also filed the patent for that. And we have used non-contact water label sensors to monitor and control the input and output of this water into the conical funnel. And we have used some solenoid valve controllers like L293 drivers, linear stepper motors, overhead steerers. So many different actuators and sensors are getting integrated to this form. And this is what our testing site. So we have one conical funnel. In this, we are taking out the water from the main harvesting tank and putting into this particular conical funnel. And there we have some sensors like pH sensor, dissolved oxygen sensors. These are connected with this single board computers. So this is what the whole thing that we have designed from the scratch, and we have write the algorithm in the single board computers to process the data. And this is what the gateway that we have connected. So it's not visible here, but I'll show you. So following a subsystem used in support to automate the control for aquaculture management. So water quality test setup we have created outside of the harvesting tank, because keeping the pH sensor continuously in the pond water will corrode its edges or corrode its electrode. So we will not get the consistent reading. So for that, we kept it outside of the tank so that whenever we require to monitor the water parameters, we can bring that harvesting tank water into the testing site. Then reagent replacement based ammonia sensor system we have designed, where we basically use the same calorimetric based testing, where we can mix the water with the reagent that will indicate the color. That color will indicate how much pH or how much ppm change is there in that particular water parameters. Then power management we have also kept, like if we are operating in the rural areas where we don't have the adequate electric supply to power this whole setup, then we have used the solar based system and the power line system connected to each other. If solar power line system is not power is not available, then our solar system will activate to keep powering the circuit that we use for this whole measurement. We have also designed automated smart feeder system, which is basically feeding to the mussels that we have put it into the harvesting tank, and recirculative aquaculture system to reuse the water by cleaning it through the biofilter. So this is a water quality test setup that we have created for testing the water parameter. We have a conical funnel embedded with non-contact water label sensor. So this conical funnel will hold the 100 ml of water. This 100 ml of water we are using to test the pH, dissolved oxygen and TDS parameters. And temperature electrode we are putting into the harvesting tank, or we are also keeping it over there. So that's how we can basically relate it to the temperature change, to the pH, dissolved oxygen, TDS. We monitor it, and after this monitoring is done, we release this particular solenoid valve, which is sealed on top of this particular conical funnel. So this water is through gravity, it will out of this solenoid valve. And then we pump the distilled water into this conical funnel so that we can remove the previous harvesting tank, any minerals that will get basically corrode to this electrode. So we are pumping this distilled water to clean these electrodes, and then we release that water as well. And that's how our setup will ready for the next experimental testing. So this is another setup that we have created for the ammonia testing. this sensor, optical sensor, is very costly. So we are not going with that expensive sensor systems. So we have designed our own experimental setup. For that, we basically created a one linear stepper motor that we have used, which will basically pushing these check valves. So we have connected the burettes with the check valves. So when this linear motor rotates and pushing to this particular check valves, it will make an entry for the air. And because of this entry into the air, these above drops will get inserted into this conical funnel. So your harvesting tank water mixed with this particular reagent, and they will generate a color. So this color graph we have, this color chart we have, and based on this color chart, if the yellow color is coming or the green color or these colors will come, will give us the concentration of the ammonia. Okay, so if it is yellowish, then too much concentration in ammonia is introduced because of the excretion of the muscles. So we will start operating our RAS systems to clean that water. So we pump this water into the biofilter and then remove clean water, we resubmit into the harvesting tank. And that's how we can managing the ammonia concentration to be get rise. Okay, so this sensor system will have the RGB sensor. RGB is a red, green, blue sensor. It's a color sensor which will basically monitoring the color of the liquid. And with this reference range of this particular ammonia concentration, we will map the numerical value. This numerical value will let us know how much will be the ammonia concentration into the water. So this is what the experimental setup we have created for the ammonia testing. And this we have actually filed it as a patent. So drop counter we have also created, because drop counter is also very costly equipment. So although we can purchase it, the commercial one, but we have created with very small IR LED detectors. So we have simply used this QRD114 proximity sensor, which is basically IR based sensor. So it has one IR LED and it has a photo detector. So this is the combinations. So red color is a LED and this gray color is basically detector. So if any drop is going through this particular, in between this particular detection sensing area, it will occult the LED light. And this is going to be monitored by the detector. Same way we have kept 4 here so that we can monitor it correctly from the multiple detectors. The feedback of the all detectors will give us the logic high, logic low. If it is getting detected any drop, it will be getting detected by all the detector. Although let's say one detector is missing out, but still we have the 3 detectors to detect it. And the majority of the boat we will be considering. So we have this OR gate will give us the all 4 detectors output is fed it into this OR gate, and this will give us the logic high, logic low based on what will be the monitoring. And that's how we detect the how many drops we required for the 100 ml of water coming from the harvesting tank to get the particular desired color. So we are adding 100 ml of water into the conical funnel and regulate it through the water level sensor. And then the reagent drop we are regulating through the stepper overhead stepper motor on the burettes to allow the water air enter into the check valve to allow the reagent flow from the burettes to the conical funnel. And then stirrer will be there that will mix that solutions, and after a second we will get the color of the liquid. That color we detect it, and then we can tell the actual concentration of the ammonia in the water. So ammonia monitoring using RGB sensor, that is what we have used it here. So this is what the reference chart that we use to detect, and what will be the wavelength of the lights that we are detecting from this RGB sensor. is basically giving us the indicated numeric value of the ammonia concentration. So if RGB and these are the range of wavelength of light will come, then it will be corresponding to 5 ppm. Then 1 ppm is very high, then 3 ppm, then 5 ppm. That's how we can fix that particular range of wavelength of light that detect by the RGB sensor. Then we have created a smart automated smart feeder system. So here we are mixing the water with the algae powder, that is green algae, spirulina algae or plankton algae. We are mixing it with water and then we are pumping it this to the this submersible pump to the harvesting tank, so that the ammonia, sorry, this green algae as a feed will be taken by the mussels. They will eat that plankton algae, and after eating it, they are basically getting removed by running the RAS systems, because the algae, uneaten algae in the harvesting tank could also reduce the dissolved oxygen concentrations, because nighttime algae will act like a reverse procedure. Okay, it will feed, it will consume the dissolved oxygen from the water. In the evening time, in the daytime, the green algae will do photosynthesis and introduce the oxygen to the water. So we have to remove this ammonia concentration buildup because of this algae bloom. So we are running, after the feeding to the mussels, we are running the RAS systems to recirculate this water through the biofilter, so that the ammonia concentration should not build up and the dissolved oxygen concentration should not go down. So they have the relative parameters. We have also connected one RTC clock. RTC is a real-time clock. So when we have to operate the RAS system, when we have to stop the RAS system, we basically have this mechanism for RAS system. So when we will give the plankton algae as a food to the mussels, it will eaten by that, some uneaten part will be floating on this harvesting tank. So we will get this water down through this particular chamber, and there is a biofilters. So we pass this water to this biofilter. So whatever the algae particles and all will get stick to this particular biofilter, and the clean water comes to this chamber. From this chamber, we will resubmit this water into the harvesting tank, and that's how we managing the ammonia built up into this particular harvesting tank, and the pH and dissolved oxygen can be maintained because of this. So this is our network design. Here the edge node and the BeagleBone AI board we have used. BeagleBone AI board because we are running some machine learning algorithms, and for that we required a good amount of processing power. So this BeagleBone AI board will offer that, and we are running our AI to this particular system, and our web server also running into this. And we are accessing it through the IP addresses that we are getting it from this gateway. And similarly, we are submitting this data to the AWS cloud server via VPN connection. So we have created one open VPN connections with the cloud server to our home gateway, so that we will not lost any of the data through any kind of intrusion attack, or any attack should limit our accessibility to the cloud. So VPN we have used to dump our data to the cloud server. So in our gateway itself, we have the open VPN services. We have used the TP-Link AC1750 dual band routers, which is basically allowing us to configure an open VPN server. So we have created one VPN server on TP-Link, and because of this server, we are connecting to the cloud with a private tunnel, and all our data is basically safe from the attack or safe from any kind of public access. This is our logical design, where we are actually visualizing all the data that we are generating it from the from the sensors. So here we have basically temperature sensor, pH sensor, dissolved oxygen, TDS, and temperature data readings, which we are visualizing it on this particular local host, which is running on the fog node. And this is the background script which is making the request, get request. So RESTful API we have used. RESTful APIs making a request for the get, put, post, delete. And that's how we are basically getting it all the data, latest data from the database that we have kept it for the latest data record, and one historical database where we are keep on recording our data for the deeper analysis of the data segments. Data analytics requirements we have, and we have to run it on the small constraint device, because we cannot run many ML models in a particular embedded devices, because they are very limiting to the computation power and storage. So we come up with the Docker container. So Docker container basically allow us to run multiple ML models by simply making a software based switching. If we can do the virtualization in the same hardware, we have very limited resource, so we cannot split the hardware for dedicated purpose for ML purpose and other processing. So we have used the Docker based container so that we can basically make the software based switching between the ML models, and we can come up with the best classification to the problem. So we are basically using the ML model for two purposes. One is for the forecasting the dissolved oxygen parameters, how much it is getting changed because of the change in the water parameter. So dissolved oxygen is our prime parameters that we are going to forecast with the very basic sensor inputs like pH, temperature, TDS. These sensor inputs are basically less vulnerable. I must say they are not too much changed. As if I can go ahead with any other sensors, they are kind of drifting their values too much. So some robust sensors we have used, and we are trying to figure out what should be the pH possibly, what will be the dissolved oxygen. So initially we have configured our sensor system with all the sensors. Dissolved oxygen sensor, we have also configured ammonia concentration, we are also monitoring, and this whole data we are keeping into the database for historical analysis, so that once these sensors start showing the drift in their measurements, we should not rely on the sensors data. We will rely on the historical evidence. So historical data basically have the relationship. When temperature, pH, and TDS values this much, there will be the deviation in the dissolved oxygen is this much. So we are considering those data also, and based on that, model is getting trained to figure out what could be the change in dissolved oxygen. If there is any change in the dissolved oxygen sensor data, then we can avoid that input sample to be fed into the machine learning model. We are simply deriving it through the historical data and feeding that dissolved oxygen value as an input to machine learning model. So that's how we are managing the sensor failure, and our measurement is also not going to be get affected. So this is our setup that we have created. So if you can able to see here, this is what the glass aquarium tank that we have. Within that we have these Lamedis marginalis species, and we are not directly putting it and they can start growing the muscles. So we are generating it by doing a small surgery. So we are opening this Lamedin marginalis muscles from the middle, and within its mantle cavity we are putting a foreign particle. Foreign particle may be a small sand particle, or maybe we can create the mother culture nucleus like kind of design. Like if you want to create a pearl of the Gautam Buddha, or a kind of any idol that you want to create as a designer pearl. So designer pearl you can create it by putting the particular design into its mantle cavity. If you want a round type of pearl, in that case, you can put a small grain of the sand, and as soon as the mussels will see any foreign particle in its mantle cavity, it will start generating the NARC. NARC is a calcium carbonate that will start depositing on that foreign particle, because it will start irritation whenever any foreign particle enters into its mantle cavity. So it will start coating the carbon NARC into on top of that particular foreign particle. And this whole procedure will take a time of 1 year to create a one pearl. So one muscles, we can create a two pearl out of it, because we can have upper layer and bottom layer. In the both mantle cavity, we can put two designer crafted shell nucleus, or either two foreign particles into the upper and lower layer. Okay, and we have to maintain that water quality parameter. As I said, the ammonia concentration when increase, then dissolved oxygen will decrease and pH will increase, and they may lead to the high growth of algae also in the water, or it may be because of the excretion from the mussels. Okay, sediment like turbidity. So how clear water is this, which is basically also indicating that dissolved oxygen is low, rise of temperature or low photosynthesis. Dissolved oxygens high in ammonia could lead to the low dissolved oxygen. So dissolved oxygen parameter is very important for, like, for a human being, oxygen is important. Same way for the muscles, this oxygen is important, which is basically a dissolved oxygen in the water. So during the surgery process, if you want to see a surgery process, many YouTube videos were there. It is just a kind of surgical instruments we use to open its mantle cavity by simply cutter that we cut. So the surgical cutter, we cut the upper part and the lower part of the mantle cavity and putting a small foreign particle into it, and then we shield it. And we have created a separate tank with antibiotic. So you have to give an antibiotic water. Within that, you put these muscles after the surgery. If the muscles survive, then we can take out after a week from that tank to the harvesting tank. If muscles is not survive, then we have to throw them out, because some time the muscles may not survive because of the surgery. They cannot recover it. So those muscles are recovered. As I said, they should be 7 to 8 centimeter in size, because they are the adult muscles. And if you can take the child muscles, or if you can take inadequate size or weight muscles, then they can die in this whole procedure. So that is also very, very important to be noticed properly. So this is what our experimental setup, we have done it. Intelligent forecasting model we have created, because we want to know what will be the change in water parameters, basically the dissolved oxygen parameters. And there are many cases when the dissolved oxygen parameters may be low. So we have to go with the aeration process by diffusing the air into the water, so that we balance the dissolved oxygen parameter. And as I said, ammonia will consume the dissolved oxygen, algae formation will consume the dissolved oxygens. Okay, pH rise could consume the dissolved oxygen. So there are many cases when the dissolved oxygen's concentration in water will change. And to maintain that, we must require the aerations. This is basically controlled by the actuators. So we have the forecasting of the dissolved oxygen parameter based on the historical data and the sensor inputs. We are also continuously monitoring the sensor value. So if sensor value is drifting a lot, let's say 1 ppm to 2 ppm change is there in the sensor readings, then either we can go with the recalibration to the sensor. If recalibration also doesn't work, then we can simply indicate the sensor is faulty. in that particular case, historical data that we recorded earlier will consider as an input to the machine learning model for forecasting the dissolved oxygen change in the water. So analyzing the performance by using a tree-based model. So we have created a lightweight machine learning model because we don't have the computational power that we want to deliver it near to the pond. So we have edge device, we have a fog device, we have created a non-linear model tree, a non-linear regression model. It is basically a linear regression model is a linear model, and non-linear model will also use the linear regressions in the tree form so that we can actually have the lighter version of machine learning model. And we observed that the machine learning model, model M3 is basically giving us the better performance. So unlike so linear model, so tree-based model we have used non-linear relationship. So we know that how the change in dissolved oxygen is possibly happened if we have the ammonia concentration rise, or there can be algae bloom. Okay, there are many such cases when the dissolved oxygen concentrations will go low. So we have to maintain that dissolved oxygen concentration, and ammonia should be get eliminated from the water through RAS system. So these two things are basically helping us to grow these pearl into the muscles. So we have used the local outlier factor. So data we have collected, historical data we have collected for the training to the model, and outliers we have removed it from the data. So that is a simple pre-processing to the data samples that we have collected from the sensors. So we have taken the pH versus dissolved oxygen change, the temperature versus dissolved oxygen change, because temperature is also affecting to the rate of reaction. So temperature is also one of the parameters that we consider. So pH, electrical conductivity, dissolved oxygen, temperature, these are the parameters that we have considered for our model training to predictions. And we have derived the correlation coefficient using a Pearson correlations. So we see that pH is highly correlated with dissolved oxygen and temperature, and dissolved oxygen is also highly related to the pH. So we have considered these two sensor readings. pH is highly correlated to the dissolved oxygen change, and temperature is also quite correlated with the dissolved oxygen change because of the temperature change. So these two water parameters are more robust, and they are not easily getting affected because of their use for time being. Okay, so we have used these two sensors and we derive our relationship. So model tree we have created, which is basically using the linear model in the non-linear fashion. So tree structure. So if you have the data, you are observing it is not making a linear relationship. So pH versus dissolved oxygen change is not linear. Same way temperature versus dissolved oxygen change is not linear. So non-linear relationship, we are basically creating it through the using a linear model. So here in this model tree construction, we divide the data into two segments, and the partial data we will try to map with the linear relationship. So linear regression model we use, and we divide them into two subtrees. Okay, so left subtree and right subtree, and we further divide this whole data into a particular segment. So that's how with the multiple divisions. So what is the model tree? Model 3, model 4, model 5, depending on that many height of the tree you can create. Okay, and that's how you can basically figure out if there can be a change in this temperature, or there is a change in the pH that could be the change in dissolved oxygen. So at the leaf node you can know the predicted outcome. Okay, so here we have this particular case for the temperature based model tree construction, where the water temperature is less than 22.1 degree or greater than 22.1. That's how we can basically subdivide this. Based on the temperature, the correlation is high, then we have the pH also into the consideration. So pH based, we can also do the predictions what could be the possible change in dissolved oxygen concentration. And we have the reference. For the reference, dissolved oxygen sensor is already there. So our analytical model in the dissolved oxygen predicted dissolved oxygen, and the actual measurement will not have much difference. So this is what the result that we have observed. So we have used various models, and we tested the M5 model tree gives us the better result comparing to the other machine learning models. So here dissolved oxygen predictions, we are getting it better performance with the M5 model tree based construction, 96% mean absolute error, and the value that is not much changing. So we are also able to see here the real value is this much for 9.121, and we are getting it very accurate to this model tree. So sensor fault diagnosis is another work that we have carried out through this whole, because we don't rely on the sensor data always, because they are easily getting changed, because chemical sensors will not survive for the long duration. They definitely get the drift in their sensor readings. So we cannot rely our all measurements or any forecast change based on the chemical sensors. Like pH is also a chemical sensor based, dissolved oxygen is also chemical based sensor. Sometimes we have the optical sensors. So optical sensors are also not very accurate one. So we have to rely on the relationship, how the historical change that we observed will basically give us the relative changes in the water parameters. As I see, temperature has a relationship with the change in dissolved oxygen. pH has a relationship with the change in dissolved oxygen. So these parameters are kind of robust, and we try to figure out with other sensor parameters. So TDS is another sensor that could measure the total dissolved solid, which can also indicate to the change in dissolved oxygen, change in the pH values. And that is, we are going to correlate with the change in dissolved oxygen. So that's how we have actually divided the sensor faults in basically 4 category. But hard fault is basically not able to be get solved immediately because it is a sensor fault coming from the factory. It is completely faulty sensor. But soft fault, intermediate fault, and transient faults are detectable fault. But for that also we have to better models to predict whether they have any change or not, because they are very transient fault, and intermediate faults are time dependent fault. So intermediate faults, they are occur very occasionally. Let's say for an hour only 1 second one reading is incorrect. If you are recording continuously for the 60 seconds, so within 1 second there can be a change. Okay, that is kind of intermediate fault. Transient fault will occur for very small period of time, very good, occasionally they can come. So they could also lead to a incorrect prediction to the dissolved oxygen forecast. So for that case, we are also creating the class for this. So 3 class classification problem, we have solved it through the probabilistic neural network. Probabilistic neural network is a feed forward neural networks, and it is basically a kind of statistical based model. So it doesn't require much training. So one go, the training is completed. It is not an iterative training process that what we see with the normal machine learning or deep learning models. So it is very fast, convenient, and low resource consuming model. So these sensor readings we wanted to analyze for the 3 basic kind of faults: soft fault, intermediate fault, and transient faults. And the fault category we have created that if it is less than 0.5 ppm fault, then sensor is not faulty. But if it is greater than 5, we go with the sensor recalibration. But if it is more than 1 ppm, then there can be a sensor faulty. In that case, we don't rely on this data. We can go ahead with the historical data measurement. So we have used the KD tree data structure to find out the historical data based on the robust sensor like temperature, TDS. These sensor data as an input to the KD tree to find out what is the relative change in the pH and dissolved oxygen. So those data, we can use it for a machine learning model to find out what will be the predictive change in the dissolved oxygen. So this is a probabilistic neural network architecture, which is a very lightweight neural networks that we use, and it is basically having a 3 basic layers. Like input layer, we already familiar. So pattern layer, where we basically figure out what could be the pattern for the particular type of fault. So we have a transient fault, software fault, intermediate fault, 3 basic class patterns. We are basically driving it through the Persian window. Basically, we use the Persian window Gaussian filters. So our Gaussian normal distribution for the particular type of fault, we are basically getting it to the pattern layer. And then for these all neurons, we can have a summation to this, and the final decision based on the probability density function, which has the highest probability of type of fault, we classify it at the decision layer. So that's how basically the algorithm will work. It use the Gaussian function. So there can be a many other Persian window functions that you can go ahead with it. Triangular is there. So same way we have used the Gaussian function, which is kind of very much easy to relate many real world problems. So Gaussian function will basically take the statistical distribution of the data related to the type of faults. So the fault model we have created by taking the census reading, census value for the particular time instances. So these data we will be going to accumulate for the type of errors that are possibly there in the sensor readings. So this is the soft fault detection model, where we have a very little discriminations, some discriminations, large discriminations. So depending on what kind of discriminations we have, when we have very close little discriminations, we use the analysis of variance. Based on that, we can identify if variance is high, it is going to be related to the sensor fault. If it is less, then there can be a small fault, or it may require some recalibrations. So ANOVA method, we can go ahead with it for the soft fault detection mechanisms. Same way, transient fault detections, we can go ahead with the transient based fault detection systems. So likewise, we have time dependent transient fault, which is basically relative to the time scale. Within a 1 minute of time frame, if there is any 1 or 2 instances where the sensor reading is incorrect, how we can detect it. So for that also we can have a Gaussian distributions. So the signal, how we are receiving the mean value of the sensor will not go much high. Okay, if there is any 1 or 2 readings are going beyond that mean values, we can consider that there can be a intermediate fault or a transient fault. So how occasionally they are occurring, that is what relative to that particular class. So I'm not going in that algorithmic part because it is simplest way to represent and understand the algorithm. Okay, so we have used a distribution table for the hypothesis, null hypothesis. So based on that, we are actually finding out a particular range or a label, and which we can basically accept or reject the null hypothesis. So normal node, r number of times at 0 is satisfied. So null hypothesis satisfied, then it is a normal node, will not have any fault. Permanent or soft fault will get detected for the r0 is detected for the particular r times. So we are taking the time scale and we are seeing it whether it is going to be for the soft fault, permanent soft fault, the time scale will be continuous. But intermediate and transient fault, the time scale will not be continuous. The fraction of time, there can be a change. So in that particular case, intermediate and transient fault will get detected. So training a PNN model is as fast as I said, like other neural network, if you can see, they required the iterative way of training the model. In this, you can directly go in one particular way, or one particular go, you can train the model. So it is very fast, very convenient, lightweight, and ideal for the constraint devices. So here the pattern layer is basically recording the Gaussian distribution. If you are using the Gaussian distribution, so distribution of the particular class will get recorded. Okay. And if any random input that you are passing it for testing it, whether it can go to this particular class or this particular class. So the distance between that particular mean values we will be considering for that particular type of class detections. So that's how we can actually, with the pattern layer, we can recognize there can be a one particular class where the particular fault is more indicating based on the sensor values. So training and fault diagnosis, we have divided this into different classes. So 3-class problem we have considered in this case: soft fault, permanent soft fault, intermediate fault, and transient fault. Intermediate fault and transient faults are occurring for a particular time period. Permanent soft fault is going to be continuous for the complete time durations. So if it is continuously being observed that the sensor value is drifting from its original value to be significant, it considered to be a permanent soft fault and it is not recovering it again. But in intermediate fault, there can be 1 or 2 instances when the sensor reading is kind of drifting from its original value. Then after a certain time period, it is recovering to the same. Then it is a kind of intermediate fault. Transient fault is kind of very difficult to be get detected because it may come very occasionally. Within a month, there can be a change. Within a year, there can be a change. So that would be a kind of transient fault. So these 3 Gaussian functions basically representing to each class, and the input that we are passing it to check the difference with the mean value of the particular Gaussian function, how much it is varying it from the initial from the mean value, the standard deviations. So this will basically classify the different types of faults, and fault detection is very important in this kind of problem where we cannot rely completely on sensor data. And it is not always be a case for a particular aquaculture. Almost any application where you are using sensors and relying completely on the sensors data, we have to test whether there is any fault in the sensor reading or sensor is faulty. Then only we can consider that our prediction model is perfectly working or kind of giving us the correct representation to whatever the actual conditions that we have. So by doing this whole experimentations, we have come up with a schedule that is idle and that does not require any kind of sensors, monitoring and control. So we have basically done this particular kind of experiment. The first data acquisition timer we set 6 a.m. So morning time we set to monitor the sensor data, because continuous monitoring of the sensor will also limit the sensor use for the long. So we have just kept a particular time instances when we feel that there can be a significant drift into the water parameter. And these water parameters not suddenly get changed. It will take a time of week. So once we put the mussels into the harvesting tank, it will take a week to change the water parameter. So it is not required that every time you have to do this particular measurements and monitoring. So that is what the most farmers are doing the mistake. They are simply doing this change in the water. Let's say they observe that ammonia is increased, so they dump a new water into the tank, and that's how the mussels will not able to survive because of the sudden change in the water parameters and the temperature scale. And that's how the farmers are not able to ripe any benefit from this businesses. So it is very important that we should train the farmers for the particular type of technologies, skills for doing the aquaculture. And aquaculture is very profitable. I will give you the basic idea. One pearl will cost around 400 rupees. 200 rupees depending on what kind of luster that you are getting from the mussels. If it is very shiny, very good looking lusters are getting it from the mussels, then it costs max to 400 rupees, and the market is available in Gujarat. jewelry businesses will attract to this kind of masses. Pharmaceutical companies are also there. They are also very much interested for this type of end product because they want to produce the medicines. Pharmaceutical companies are also, pharma not, beauty industries will also be looking towards this. Cosmetic industries will also be looking towards it. So if you can have 500 muscles, then you have 1,000 pearls you can multiply with 400 rupees. That is what the benefit you can ripe in a year. And that is what a small scale, very small scale, that you can even do it in a home. So it doesn't require a big land to harvest it. Within a small controlled environment, you can also produce a pearl, and you can also get benefited with this particular aquaculture businesses. So very, very limited knowledge is there in this area, and even the Indian farmers are not looking towards these profitable ventures. And in many foreign countries, they are getting a benefit from this kind of businesses because they are technologically enabled. They are very much having the educated population to train with it. So with this, I close my session. If anyone has any doubt, any questions, they can simply ask. Thank you very much.
Thank you, sir. Audience, once again, if you have any question, please ask. Yes, you can write in the chat box also. All right. Obviously, this is very new topic. So if you have any question, please ask your question.
So from this research studies, we basically published 2 papers in IEEE journal and 1 patent. And we also have going for the technology transfer with one company in Ghaziabad, which is basically Biwa pearl farming. So that is also doing the kind of business. And currently also we are working on microalgae production, which is basically a next generation biofuel. So if anyone interested in that area also, they can pursue to that direction. So green algae production or a microalgae production is basically using for the biodiesel. Biodiesel is creating through that microalgae.
Sir, a question is asked here by Vivek Gupta ji. Please specify, is there any sensor for micronutrition?
Micronutrition, that I don't know exactly. Is it possible or not? But I think spectro images you can use for that particular purposes. Spectral imaging cameras are also there, and spectrography is there. With that, you can actually figure out what is the micronutrients there in the particular food item or whatever. But as sensor, I don't know. But imaging sensors are available. They can actually give you some idea, or some kind of spectro images that you can also generate. Yes.
Thank you, sir. Thank you for this wonderful session.
Yeah.
And
Thank you.
now we will proceed for vote of thanks. So here I invite Professor Deepanjali Dhanukji to propose vote of thanks.
Good evening to everyone. On behalf of IPS College of Technology and Management, Gwalior, I extend heartfelt thanks to our esteemed speaker, Dr. Munish Singh, Associate Professor CSC, NIT Delhi, for an insightful and inspiring session on IoT in agriculture. Your valuable perspectives on smart farming, sensor networks, and real-time agricultural monitoring have truly enriched our understanding and motivated us toward innovative research and practical implementation. Thank you, sir, for sharing your expertise and for the engaging interaction. I also appreciate all participants for their active involvement and enthusiasm. Once again, thank you, sir.
Thank you.
Thank you, sir.
So thank you all
Thank you,
the
Munish sir, for coming to this
organizers
session.
and the participants. Yeah.
Thank you so much,
Okay,
sir.
Yeah. Thank you.
participants, once again, the feedback link is given in the chat box. Please fill it and submit it. As we know, it is mandatory for all the participants to attend and fill the attendance of your feedback for attendance purposes. That's why please do it. There is a next session very soon, so stay online here.
So within the 2 minutes, we will start the next session. So we ready, dear participants.
Participants, there is an important message also for you all. As we know, there is a test after this session and after the validatory basically. This session, after this session, there is a validity part. After that, the quiz. So these all are set for all of us to be present in that and take part. Participant attendance is already uploaded in the Atal portal. So if you need to check, please check there your attendance.
Vinny sir,
Yes, sir.
Dr. Dhirendra Singh already joined us.
Okay.
So, sir, good evening and welcome you.
Good evening to all, and thank you. Thank you very much.
So, Vinny sir, let's start the session.
Sure, sir. Let's start. So good evening, everyone. So I invite Dr. Dhiren Pratap Singh ji, Associate Professor, Manit Bhopal, to deliver talk on machine learning techniques in the extraction of Earth features from very high resolution remote sensing images. But before this, um, I would like to say about Dr. Singh. Dr. Dhiren Pratap Singh ji is an associate professor in the Department of Computer Science and Engineering at Maulana Azad National Institute of Technology, Bhopal. He earned his PhD in Computer Science and Engineering from Manit, Bhopal in 2015, following his postgraduate degree in Intelligence System from IIIT Allahabad. Prior to joining academia, he worked as a software developer at Coreforce Technologies Limited, New Delhi, India. With over 18 years of teaching and research experience, Dr. Singh's research interest includes machine learning, image processing, and high performance computing. He has published more than 75 research papers in reputed international journals and conferences. So now it's time to hear from our eminent speaker, Dr. Singh. Sir, it's over to you.
Okay, thank you, Vinit, for nice introduction. Let me share my screen. Okay, my video is not working over here, but I'm going to share my screen. Please let me know. Okay. This my screen is visible to you guys?
Yet not, sir.
Not?
Yes, sir.
No, not yet, sir. Is it visible, Vinny, sir? From your
No,
side?
not visible.
No, sir.
Just wait a minute. Let me check what is happening. What about now?
Not yet, sir.
Not.
Not yet.
Still not visible?
Yes, sir. Still not visible, sir. Sir, reconnect. If it is better, please reconnect in the session. It may.
Just wait a minute.
Okay, sir.
Yes, now, Raju?
Now, yes, sir. Visible, sir.
Yeah, it's visible now.
Yeah, yes, sir.
Okay, that's fine. So, good evening to all of you. Good evening to all participants and organizer of this event, PDF. Okay, so let's start. This talk is actually about, I hope you guys have gone through so many machine learning and AI, all those things already. I'm going to discuss about many techniques again. So let's go with it with me. So this is actually about machine learning techniques in the extraction of Earth features from very high resolution remote sensing images. So when we talk about remote sensing, actually here I'm going to talk about basically satellite based remote sensing, because remote sensing can be drone based and we can use some other aerial vehicles as well. But here, whenever I talk about remote sensing, it's about the satellite imagery. Okay, so the content which I'm going to cover over here for you guys is we'll talk about basics of the remote sensing and this high resolution satellite imagery. Then we talk about the challenges, like if we have the high resolution satellite images, then what are the challenges we are going to face with that? Then with the help of these high resolution satellite images, which type of features can be extracted and what are the advantages of those features, which type of task can be completed with the help of those extracted features, and talk about some machine learning techniques which are actually used for the feature extraction from the satellite images. Okay, and what are the basic flow of that? Then we will move to the deep learning. Okay, because nowadays we actually use the deep learning, not very much the machine learning techniques. Use sometime machine learning, but these days people actually go with the deep learning and all those things. So we'll talk about specific deep learning techniques. It's basically convolution neural network and some other neural networks, CNN architecture, which are pre-implemented and pre-trained. We'll talk about them. Then the UNet, one of the architecture which we use in case of satellite image processing these days, and there are so many variant of the unit as also available. And then we'll talk about some of the future trends. So this talk is actually about if you want to go with some kind of a research with remote sensing images, and you have high resolution satellite images available with you, then which type of advantages you are going to have, or which type of challenges you are going to face, and what techniques you can use to extract the features which are of your use. Okay, let's move to the actual content introduction. Okay, I hope you guys have gone through some of the previous topic here and seen people have talked about some remote sensing things. So let me revise it again to you guys. So remote sensing is actually collecting the information about the Earth's surface. And when we talk about collecting the information about the Earth's surface, most of the time we capture the images. And we capture the images without contacting the Earth's surface. So how we are going to do that? We use the satellite images, we use the drone, we use some UAVs where the sensors are installed, and those sensors are used to capture the satellite images, capture the images. Okay, so those sensors can be installed in the satellite or drone or any kind of unmanned vehicles or any kind of aerial vehicles. Okay, so different types of sensors are used to capture the data from the Earth's surface. It can be radar data, it can be simple images, gray images, color images, or sometimes multispectral images. Like in journal color image, we have just 3 bands RGB, but when we talk about the satellite images, are the sensors which we install in a satellite or aerial vehicles, these sensors are going to have a multiple spectral band, not just red, green, and blue. So we capture the images, we capture the data in a different spectral band. Sometimes these spectral bands can be up to 100 different bands. Okay, so different kinds of features can be extracted from those bands. And then when we talk about high resolution, before going to the high resolution, we should have the idea about what is the meaning of the resolution. Resolution means, when we talk about resolution in a image and with respect to Earth's surface, so like if we are talking about, like I have written over here, the high resolution images can have the resolution, spatial resolution, sometime less than 1 meter. It means the one pixel which will be represented inside the image, it is going to represent 1 meter cross 1 meter surface area on the Earth. Okay, so 1 meter cross 1 meter surface area you are representing with the help of 1 pixel. It means your resolution is 1 meter. 1 meter of the satellite image. And these kind of resolutions are called very high resolution satellite images, because normal satellite images contain the resolution around 20 meters, 30 meters. Okay, but nowadays we have the satellite images which are giving us the images resolution less than 1 meter and sometimes few centimeters. Like the highest resolution commercial satellite these days available with us is of Maxar technology, WorldView 3 and WorldView 4 satellite, which are giving us the gray images, panchromatic images actually, and the resolution is just 31 centimeters per pixel. Okay, very much similar to the images captured by the drone. So if we are capable to collect such type of images from the satellite data, so these help us to detect and identify the very minute features which are available on our surface. Like some content I have written over here, you can identify the individual buildings in the cities, you can identify the road networks, and some others small scale features as well. Even though you will be able to identify the vehicles, individual trees, small water bodies, and all those things can be identified with the help of these very high resolution satellite images. So if this type of facility available to you, this excuse me, this can be used in a different kind of applications like urban planning, infrastructure monitoring, precision agriculture, disaster response system, okay, where knowing the exact location and the shape of all the objects and features are very important to us. So in those cases, this high resolution satellite images are very important, and the processing of these satellite images can help us in a different kind of applications, different kinds of requirements in real life. Okay, so but if you have very high resolution satellite images, these are giving us many challenges, like working with the high resolution satellite images is give you very complex environment. If you have capture a very high resolution satellite, very high resolution image of a city area, a highly urbanized city, then what will happen over here, over there, that environment capture inside that image will have so many heterogeneous informations over there. So many features will be there, buildings will be there, roads will be there, some vegetations will be there, one building shadow to the another building, so many things will be there. So extracting the exact features from such type of images where so many features are overlapping to each other, so many features are densely packed and closely intermixed with each other, it's required very precise algorithm implementation. Okay, similarly, spectral similarities. What happened when we are capturing the images with the help of satellite sensors, sensor installed over there? Many times the spectral features reflected by different objects can be similar. Or if we take the example of in cities, you can have the rooftops of the buildings and the roads, maybe concrete road, which look very much similar to each other. If you are working some kind of a project where you have to differentiate the buildings and road network and all those things, this will make complex to you to work in such type of images even. And data volume, if resolution of the images is very high, then the size of the data, size of the image in terms of where we require to store it, process it, it will be very high. So data volume will be very high, and you know that when the data volume is very high, the processing of such type of data will be required. You will require some extra machines like normal desktop or laptop will not capable to cater them. You will be required some high-end processing machine. You will be required the graphics card installed on your machine to work with these type of images. Okay, like if you are working with a 10-meter resolution image, and if you now required 1-meter resolution image, then the 1-meter resolution image size will be nearly 100 times more than 10-meter resolution. So these high resolution satellite images are giving us so much informations, but the dealing with them, processing with them is also going to be very complex. But we use them. Oh, okay, I have just taken us this is the Google image. Google is giving us the high resolution images. So you can work with if you want to work with, you can get the images from the Google Earth Engine. So many different satellite images are freely available over there, and you can extract them. I have taken this image from just the Google image, Google Earth site, It's just giving a part of Manet where you can see that so many plants are there which are overlapping to each other, buildings, and you can see the roads and roads and rooftops of the buildings look very much similar to each other. If you will go and work with these kind of images, even though they are high resolution images, this will be very complex. You will be required a really good training data set to work with such type of images. Okay. So yes, now images is available, even though they are giving us a very complex information, but working with high resolution images are going to be very useful for us. Because with the help of such type of images, we will be able to extract different kind of Earth surface features. Okay, like build up and man-made features. Built up and man-made features like building or structures made on a cities, building, rooftops, industrial complex. We can easily identify which are required for urban mapping and urban planning. We can identify the transportation network, road network in the cities, and all other urban features which are required when we are doing the urban planning, parking lots, bridges, sports ground, sports field, and all those things which are required for the urban planning. All those things can be extracted from the very high resolution satellite images. Then talk about the vegetation and land cover. So with the help of these images, we can easily map the vegetation available on urban cities or anywhere. So if we talk about the urban areas, we can map the trees available over there, which are the garden places. We can identify the green rooftop areas. We can identify the forest and natural vegetations. Even though we can work with the crop and agriculture field, and we can identify what type of crops are growing in a particular field. Okay, all those things can be done. We can have the water bodies. We can identify the rivers. We can identify the streams, canals. All those things can be identified. Ponds and lakes can be easily visible and extracted from very high resolution satellite images. Then talk about the barren land and soils. We can identify where the exposed soil is. The sand areas are there, barren land is there, which are actually we use this type of information where we are talking about land degradation and desertification. If we are doing the study of land degradation and desertification, we required to get the information about the barren land or what kind of a soil over there. Or we can identify the construction sites where the new constructions are going on. Then come to the transportation and linear features. You can work with identifying the transportation line, railway tracks, utility lines like pipelines and some other power lines, even though that can be identified. Then natural features, mountains, hills, and some other geological features which are required for mineral exploration and all those things that can be extracted from the high resolution satellite images. And this last one, the land use and land cover classes. So many people working on that, a famous research topic, land use and land cover classifications, where we just classify the images where the residential, commercial, and industrial zones are there, where are the parking places, playgrounds are there in the urban areas. Okay, so if we have the high resolution satellite images, we can extract different kind of earth features. But to extract these features, we require the concept of the machine learning. We required machine learning and the latest technologies which are now available with us. So let's move to the next topic. It's actually the machine learning. Nowadays we are working with the machine learning. Initially people were using the simple concept of image processing and trying to extract the features from the satellite images, but we can use nowadays the machine learning. This kind of facilities are available, and the reason behind that, we have such type of machineries, such type of workstations easily available to us, where we can easily work with the high resolution satellite images. Okay, so I hope you guys have the basic idea about this machine learning thing. So we are not going to much detail, but give some basic idea. So machine learning, as you know, it's a success of artificial intelligence. And nowadays we are using this machine learning concepts in everywhere. Just talk about any areas of research or any area of real world, we are using somehow concept of the machine learning over here. And what it is actually, it's the ability of a machine to learn from the data. It's just ability of a machine from learn from the data, improve its performance. And the basic idea is that we are not going to have any explicit programming over there at the backend side. We are not going to explicitly programming. The algorithm should learn by its own. It should get trained, model should get trained by its own somehow. It should improve its performance step by step. So that's the basic idea of the machine learning. So, and in machine learning, what we are doing, we are implementing so many algorithms, our statistical model. And what these models are doing, these models are trying to learn the patterns in the data supplied to them. Okay, and on the basis of their learning, they make the predictions. You can use it, use those trained model for your future purpose. And one of the most important thing whenever we talk about the machine learning, what kind of a data you are going to supply during the training of that model. Okay. If you are going to supply a good quality data, it means your model is going to perform better. So everything depends on the data. Like now you have the satellite images, but if it's a good quality, then your model will perform better. But it's the data you have supplied, it's not of a good quality, then your machine learning model is not also going to perform better. No? So that's a very important thing whenever we talk about the machine learning. So I'm just talking about some basics. I hope you guys know about it. So I'm just going to give some basic overview about machine learning techniques. Generally, it's classified into two categories, supervised and unsupervised. In case of supervised learning algorithm, the important thing is that you should have the labeled data available with you. And whenever you are going to train a model, you have to supply the input and output, both the things. And accordingly, according to your data you have supplied, what the model is going to do, model will try to learn it, try to find out what are the features available on that data, so that I can map input to the output. Okay, and after that we can use that model to predict unseen data. Okay, and the most important part whenever we talk about the supervised learning, you should have a large amount of labeled data. Okay, labeled data should be available if you are going to work with the supervised machine learning algorithm. And actually there are two kinds of work we do in case of supervised machine learning: classification, where we try to divide our data in some categories, and sometimes regression, where we try to predict some continuous value. We'll talk about in terms of remote sensing and earth features. You can have classification like land cover mapping. Try to divide your land cover area on a different class. It's an urban area, it's a forest area, it's a water body area, what it is. So categorizing it, and there are so many algorithms to do that. Like if we talk about the classification algorithm, famous one like support vector machine, random forest, KNN algorithm. There are so many supervised classification algorithms are there. Then in case of regression, if we're talking about earth features and concept of regression, so it could be evaluating the forest cover, how much forest cover is present in somewhere. So estimation of the forest cover. It's a continuous numerical value, and you can use the regression, logistic regression concept, not linear regression, and some other decision tree regression, random for or support vector regression to do that. Okay. And when we talk about unsupervised learning algorithm, yes, the important thing, if you don't have the unlabeled data, go with the unsupervised learning algorithm. And how these unsupervised learning algorithm works, actually, these algorithms try to find out the similarities and dissimilarities between the data supplied to it. And on the basis of similarities and dissimilarities, it try to group the data. It make the groupings on the data. Okay. So the common application of it is clustering of the data, where we can create the group of similar kind of data points. And second one is the dimensionality reduction. If you have a high dimensional data, so what we do in case of that, we try to reduce the dimension of the data without losing the important features. Okay, PCA is one of the famous approach, principal component analysis. We use to do that. And we talk about clustering. K-mean clustering algorithm is one of the famous one, which we generally use with the satellite images. Okay, so this is the basic idea of machine learning, supervised and unsupervised machine learning approaches. Okay, this is the standard one. We generally, whenever we go and work with the machine learning techniques, we have to follow something like that. We work on the data acquisition. So these are the basic steps whenever we are going to work with the machine learning algorithms, machine learning model implementation. We have to go with that. So data acquisition, if we are talking about the remote sensing data, here your data is going to be satellite or aerial sensor data. It can be multispectral, hyperspectral data, or radar data, any kind of data capturing the Earth surface images. Okay, then if it's a remote sense data, some data pre-processing steps are very important, like geometric correction. You have to align the capture images with the actual Earth curvature, actual Earth data. You have to align those images. Okay, like you have to make the fix the latitude and longitude of that image. Then sometime you require some kind of image enhancement. You have to do contrast stretching, normalization of intensities over there. So they are the basic data pre-processing techniques which we have to apply. Some kind you can go with the data fusion as well. So if you have a data for a single place, you can merge the data of a different dates, like one data captured today and one data captured after 1 week. So you can merge those data or combine the data of multiple sensors. All those can be done in the data processing techniques. Then one important step, okay, training data preparation. If you are going to work with the supervised, you have to label the data. So for the labeling of the data, we have to do the field survey or sometime expert interpretation. From very high resolution satellite images, experts can easily find out what kind of features, what kind of objects are present in a particular location in that image. Okay. Then feature extraction. If we are talking about simple machine learning techniques, you are going to apply on your satellite image data. So feature extraction is one of the important step over there. We have to apply some kind of feature extraction techniques. These features can be spectral features or spatial features. Spatial features like shape of the object present over there, texture of the objects present in the image, edges or boundaries present in your image. A spectral feature, if we are talking about classification of some vegetation kind of thing, we extract the feature like NDVI, normalized difference vegetation index, which is actually a difference of two different wavelengths. Okay, and very much similar to that, we can extract some other feature like soil adjusted vegetation index and some other features. So many things are there. You have to go with that, like which type of project you are working, which type of research you are working. Accordingly, you have to extract the features, and those extracted features are now applied to the model. Whatever model you have to select, you according to your requirement, you have to select a model. And then these extracted features are applied to the model for the training purpose. And after the training of that model, you do the assessment. And assessment, for the assessment, one of the standard method is create the confusion matrix, where we compare the ground truth with the classified result given by your model. And you can calculate different kind of parameters on the basis of the confusion matrix you have created. And for the unsupervised learning, there are so many other matrices we use for the assessment of the model. Okay. And then finally, if your model is available, model is trained, performing well, you can deploy it. You can use it for the real world application. You can deploy it for the use inside the real world application according to your requirements. So these are the basic standard steps. If you are going to work with the machine learning, you have to use it. There are some very standard machine learning approach which actually used in case of working with the satellite images and high resolution satellite images. One of them is support vector machine. It's a really good one. If you are working with the high dimensional data, support vector machine is working really good. Okay, so the idea of support vector machine, I hope you know about it. So the idea of support vector machine is like what you do, whatever data. Okay, so it's a supervised machine learning algorithm. It means you have a label data available with you and actually used for the classification. Some kind you can go with the regression use of the SVM as well. So idea of SVM is it transforms your data to high dimension, and then after transforming into the high dimension, it try to classify it. As simple as. Okay, and it's this SVM is very effective in finding the land cover type. It's about vegetation or water body or urbanization. Okay, and good thing it's work with the limited data. If you have just limited data, you can go with that, because I will talk about the deep learning. So in case of deep learning, you should have a large amount of data available to you. If you basically, if you want to go with the basic machine learning approaches, they are going to perform well if you have just an amount of data. If you have a huge amount of data, then you can go with the deep learning and all those things. But huge amount of data, labeling all those data, it's also going to put extra burden. So sometimes we need to work with a small amount of data. On those cases, these basic machine learning techniques even are going to give us the good results. Okay, another machine learning approach is random forest. Random forest is an ensemble method which construct the multiple decision trees, and those decision trees outputs are used to find out the final decision, final output, or like one particular data point belongs to which class. It will be decided on the basis of majority voting for the classification, and we are going to find out the mean value in case of regression. And what the advantage with the random forest is really good it avoid the overfitting. Okay, and keep the good feature with you. So it's a really good one. We can go with the random forest. We are working with the satellite images. Then k-nearest, very simple algorithm, very simplest one to implement. There is no training required. Whatever data you label data will be available to you. That's all is the trained model. But okay, at the time of testing, then it's going to take time, because no training cost, but at the time of testing, it will take time. If you have a large amount of data, then it's not good to work with the k-nearest one, because your testing time will be very high. But it's very simple to implement. no explicit training is required over there. So if you want to work with, you can go with this k-nearest neighbor as well, KNN method as well. It's just I've taken some example, the different satellite images, Landsat, Sentinel, and Planet. These are the different satellite images, and it's some area of Ganga Basin. And by using the SVM classifier, we have tried to classify it into 6 different classes. Okay, water bodies are represented with the help of these dark blue, and then vegetation area dark green, and then agriculture light green. Wetland area is represented with the help of red point. Then some building structure represented, build-up areas are represented by blue, yellow area. Okay, so it's land cover classification by using the SVM. So we can use these methods for satellite image processing. And this again, the machine learning. We have used the basic machine learning approaches, and these are again land cover classification. Land cover classification for these are for the different algorithm. Like first one is the SVM, second one for the rest, second column is random forest output, third column is from the KNN, and fourth one from the neural network. Okay, and these images from the Italy, some mountain area of the Italy, some coastal areas of Italy. Okay, and we have classified into the 10 different classes. Okay, now I want to move to the deep learning side, because these days actually we working whenever we talk about satellite image processing. Now we are working with the deep learning approaches. So before going to the deep learning, we should have the basic idea about the neural network, because most of the deep learning approaches are implemented on the top of this neural network concept. So neural networks is a computational model inspired by the structure and function of the human brain. Like very much similar to the human brain is having billions of neurons which are connected to each other, and their connection shows how much learning they have. Okay, a strong connection between different neurons in a human brain, it means a strong memory, something like that. So what we have done in case of neural network, we have a mathematical representation of neuron. Mathematical neuron is like artificial neuron is a mathematical representation of neurons available on a human brain. They can do very much similar thing. They collect the data from they collect the input data, they process it and produce some kind of output. Okay, and when we talk about the neural network, it means multiple artificial neurons are connected with each other, and those neurons are present in a different layers, multiple layers. Okay, so whenever we talk about neural network, there are some basic principles, like there are different layers of the neural network. So neural network typically have input layer, multiple hidden layers, and then the output layer. Input layer from where you are going to give the input to the neural network. Hidden layers where all the training and learning take place, and output layer where they are going to produce the output. Then learning means adjusting the weight or connection between two different neurons. During the training, we adjust those weight. Like the connection between two neurons are always given some weights, and during the training, these weights are updated. And different algorithms are used. We are not going to talk about those algorithms. And the important thing with the neural networks are that they try to capture the non-linear features which are available on the data set. So they are really good whenever we are going to work with the images. And here we are talking about remote sensing images, satellite images. So neural networks are really good to work with the remote sensing images. This is the basic structure of the neural network. We have the input layer, hidden layer, and the output layer. Here we have 3 different hidden layers, and every circle is representing one neuron. Okay, so now move to the deep learning. So deep learning is a specialized branch of machine learning, uses artificial neural network with many layers. Here deep is deep neural network. Your neural network should have at least 3 or more middle layers over there. Then only you are going to say your neural network is a deep neural network. Okay. And whenever we talk about the deep learning, the important thing is that, like in case of machine learning, before giving the data to the model, what we were doing, we were extracting the features from our images, and those features are given to the model for the training purpose. Those features can be spectral feature, or those features can be spatial features. Any kind of a features can be taken, but you have to extract the features. You have to apply some kind of a feature extraction algorithm. In case of a deep learning, there is no need of applying any kind of a feature extraction. Your deep learning model internally going to extract multiple types of features and use those for the future classification or whatever you want to work with. So deep learning does not require any kind of feature extraction technique. But yes, one important thing is that most of the time when you are working with the deep learning, you should have a large amount of data as compared to the machine learning technique. Even though some of the machine learning technique work good with even a small amount of data, but if you are working with deep learning techniques, we should go with the large amount of data. So the key characteristics of the deep learning: multiple layers. So multiple layers, you should have multiple layers of the neurons over there in case of deep neural network. Automatic feature learning, yes, they extract the features automatically. There is no feature engineering is required. They can handle unstructured data. They can handle easily. They are really good for the videos, photos, audios, natural language processing. Deep learning technologies are really good one. But the important thing, whenever we are going to work with deep learning, you have to use a large amount of data. Okay. And the working with deep learning technique is very much similar to the machine learning. You should have the data collection. You have to pre-process it. Sometimes you require pre-processing over there, or you can supply the images without pre-process. Simply resize and basic pre-processing algorithm may be required. No feature extraction is required. All the feature extraction will be done internally by your model, your neural network. Okay, you just need to have a proper model for your problem. Okay. Then the training, you can select the training algorithm, whatever method you want to use over there for the training of that. And then finally, the testing purpose and all those things, all are very much similar to the which we are using in the case of machine learning, very much similar to that. Okay, one of the most important deep learning architecture is convolution neural network. Whenever we are working with the images, convolution neural network is one of the most important model which we use. Okay, so what's the convolution neural network? Convolution neural network is actually, let me show you some images. It's something like that. So there are some basic layers over there. Whenever we are going to work with the convolution neural network, it is going to have one basic layer that is called the convolution layer. Okay, convolution layer is the foundation block, I will say, for the CNN model. Okay, in case of when we are using the convolution layer, what we do, we use some learnable kernel whose values are going to be updated during the training, learnable kernel, and those kernels are move around to the images. It's something like move around. We don't move actually physically, but it's feel like we are moving around to the images. And such type of multiple kernels we use, like you can see, we have one single image, and that small box is showing one kernel, and this just corresponding to this one kernel, we have generated one output feature map. So in every convolution step, we apply multiple such type of kernels, and due to that, multiple feature maps are generated. So after first input image, the first layer of features map you can see. Where you can see the first layer of feature map. Okay, and then such type of multiple convolution layers can be present in your actual neural network, convolution neural network. Such type of multiple level of convolution operation can be performed. So one layer is the convolution layer. Then the second important layer is batch normalization layer. What we do actually, after performing the convolution, we normalize our data. Most of the time we normalize our data. This data normalization make our learning process faster. Okay, learning process faster. So after batch normalization, we use the apply a ReLU activation layer. Activation, this ReLU is a famous one, the non-linear activation function, which actually remove the all negative output. If it's less than 0, it will be removed. Only the positive entries will be there, and it actually introduce a non-linearity in your feature map. Okay, then the pooling layer. Pooling layer. The purpose of the pooling layer is to reduce the size of the feature map generated by the previous layers. It reduces it, and while it's reducing the feature map, it's keep it in mind. You have to keep the important feature available over there. So generally, max pooling. We use the max pooling, and we use the kernel size 2x2 or 3x3 in case of pooling layer. Then after pooling, there is flatten layer. Flatten, where all the features which are generated are represented in form of one-dimensional feature. Okay, because all the feature which we are extracting during the previous layer are going to be a two-dimensional data. Such type of multiple layers will be there, but every layer, every data will be, every feature map is going to be a two-dimensional feature. And this flattened layer will make a one-dimensional feature vector, and these feature vectors are now the actual features which will be supplied to the fully connected neural network. Neural network, as you can see over here, fully connected. It means in every layer neurons is totally connected with its previous layer neuron. Okay, so it's fully connected. So flattened layer output will be supplied as an input to the fully connected neural network, and this fully connected neural network is actually going to produce the final output, whatever output you want to get. It's performing the classification or some other things. Final output will be produced by this fully connected layer. Okay, so these are the basic layers which are available on this CNN architecture, deep CNN architecture. So I've taken just one example over here. It's again doing the land use classification. The deep learning, this deep learning architecture have classified the data into the 5 different classes. It's showing the second image is showing the zoomed center place. Just the first image is the actual classification of the image in 5 different classes. Okay, so there are some standard deep learning models. Pre-trained models are available. Like one of them I have taken over here. It's giving it's a ResNet 50. It's a famous model. It's a pre-trained model available. So why I'm talking about this model over here, because the pre-trained one, you can use pre-trained model for the transfer learning, where you will use the actual model, just remove the final fully connected layer of that model and create your own fully connected layer, and do whatever classification, whatever output you want to produce. You can produce that kind of output from that fully connected layer, but the previous layer of the model will be as it is. Okay, and these are the pre-trained for millions of images, like this ResNet 50, because it's this model is having 50 layers of different kind of a processing. Like block 1 is saying one group of processing, convolution, then the batch normalization, ReLU, max pooling, and the second is showing convolution, ReLU, and batch normalization. Such type of 15 blocks are there. Then convolution and batch normalization, 10 blocks are there. 2 convolution and 2 batch normalization, 12 blocks are there. So totally internally 50 blocks are there. So what we do, we use these kind of pre-trained model like ResNet, GoogleNet, InceptionNet, Inception V3, one of the famous model. All these pre-trained models are available, which are already trained for the images. So you can use these models for your purpose, your job, your classification work. Just use that concept of transfer learning, remove the final fully connected layer, and supply your input. These models can easily get trained and perform better than if you are going to design your model from the scratch. Okay, this is an example of classification of a data. It's flood data of 3 different areas, 3 different years of Ganga Basin area. Okay, they have used the deep learning model, multi-layer perceptron classifier, to classify the images into 10 different classes. Okay, so we can go with these type of deep learning model as well. Okay, it's a description of that. Okay, finally, let's talk about one of the famous model that is called UNet model. So UNet is actually created for the medical imagery, and initially researchers have started using it for the medical image segmentation. Segmentation is a process where we are going to give assign a class to every pixel of the image. Okay, so UNet are used for the segmentation purpose. Segmentation, where we are going to give a class to each pixel of the image. Okay, and UNet is a fully convolution neural network. Fully, it means it will take a image input and it will produce a image as an output. But maybe it will be a segmented image, and it's really good for remote sensing images as well. We are using it. We have used it for the segmentation, building segmentation and road segmentation of the images in the satellite images. You can see this is the structure of the UNet. There are so many now variants are also available for the UNet. So this is the structure of the variant. That's why this is called UNet. This architecture look like U. That's why it's called UNet architecture. So this UNet architecture is actually having 3 parts. People say 3 parts. First one, where we are reducing the size of the image and extracting the feature, that is called the encoder part. You can see the input image size is reducing step by step, and at the middle level, at the bottom of the U, you have that is called the bottleneck image, which is having the maximum features over there. And then the right side of the image, that is called the decoder part, where from those bottleneck features we reconstruct the image We reconstruct the segmented image. During the reconstruction of the segmented image, we use the skip connection. These black arrows are showing the skip connection. Skip connection, it means what we do during the reconstruction of the image, we use the features available during the encoding of that image. We don't want to lose the spatial features over there when we are reconstructing the image. And finally, this unit is going to produce a segmented image. Like here, your input image is going to be 572 cross 572, and output image is going to be 392 cross 392 pixels. Okay, so mostly it's going to at the final level it will be a segmented image. Only two classes will be there available over there. Most of the time, two classes will be available. Two class segmentation we use. So it's a really good one, a really good model. And there are so many variants are available where you want to segment, like you just want to segment the roads in a city, or you want to create a model which can segment all the rooftops area of, like we have created this one building segmentation. From this image, it's segmenting all where are the buildings. Maybe it's not correct in giving the 100% accuracy, but it's extracting. It's a segmented image. Only two colors are available. One is building or non-building, nothing else. Okay. So if you are working for any kind of a segmentation, water body segmentation, road segmentation, or rooftop segmentation, we can go with the UNet models as well. Okay. So this about the deep learning models which we are using in these days for the high resolution satellite image with the high resolution satellite images. Okay. Then let's talk about the future trend. What we are doing now, what people are going with, doing with the high resolution satellite images. So now we are trying to integrate the data from the multiple sources, combining the very high resolution satellite images with the LiDAR data, combining it with the SAR data. Okay, because combining the data from the multiple sources enhances the spectral and spatial features. Then real-time processing. We are working with the real-time processing. People are doing the research of real-time processing. Okay, mostly the real-time processing we do in case of a drone images. We can do with the satellite images if the real-time satellite images are available to you. But most of the time we use the drone images, where the remote sensing images are captured by the drone. The sensors are installed in the drone, cameras are installed in the drone, and those images are captured. And these images, these real-time processing can be used for real-time disaster management and some other applications where the real-time help is required. Then people are going with the explainable AI. Maybe I hope you guys heard about the explainable AI, because the problem with the artificial intelligence and deep learning and all those things is that how these models are internally making the decision. Most of the time we don't have the idea about that. Those are just a black box. If we talk about the deep learning, actually, those models are represented like a black box only. Internally, how those are making, how the decisions are made, we don't have the idea about that. Or what are the features they have learned? What are the things they have learned? We don't have the idea about that. So people are working with the explanation AI, explainable AI, because sometime when we are working with the critical application like disaster response system or environmental monitoring, infrastructure monitoring, the trust of the model is also required over there. Okay, not just take the model and get the output from that model. That's not going to be just sufficient for that us. Okay, then self and few short learning. Less reliance on labeled data. When we talk about high resolution satellite imagery, or we talk about deep learning, we required huge amount of labeled data, and labeling of the data is itself a problematic task, or you can say a burden whenever we are working with the model design or something like that. So we have to keep it in mind, so that now people are working with designing of the model where the less amount of labeled data is required to train those models. Okay, because it's going to be help us in a big way. So that's all from my side. Okay, thank you all, and your questions are welcome. One thing I just want to tell you, these days we are able to work with the deep learning just because of the type of machines available with the you. Because with the help of graphics card, you can simply convert your simple machine into a supercomputer kind of thing. So that's why it's possible to you to easily work with high resolution satellite images and go with the deep learning model, whatever you wants to be. Okay, and they have their application in a different areas. So you can go with the working with the high resolution satellite images for your research as well. Okay, thank you all. That's all from my side.
Thank you, sir. Audience, if you have any question related to this, please ask. Time to ask your questions, your queries. So all are requested to ask your question. Okay. So we are waiting for 30 seconds more. If you have any question, please ask. Sir, a question is asked, but not in the chat box. That how to decide which model is better for which condition?
Okay, so models are actually decided like what kind of a data available with you. One thing, like you have a very most of the time working with the satellite images, if label data is not available and labeling is required from your end side, you have to do the labeling. It's sometimes complicated. Okay, but actually so many helps are available on that side as well. Google Earth Engine is really good one. If you guys have not worked with the Google Earth Engine, if you want to work with the satellite image processing, drone image processing, you can go with the Google Earth Engine. This will help you in a big way to create the data, get the data, satellite data for those satellites which are freely available. So there are so many satellites from which data is freely available. So if data is available to you, less amount of data, go with the simple machine learning algorithms. If you have a large amount of labeled data, if you are capable to do that, go with the deep learning technique, because deep learning techniques are really good to capture the non-linearity which is available on these images, and they are really good with the image data set. But only requirement you should have the large amount of data, and the data creation itself is going to take huge time. So if you have the data, large amount of data, go with the deep learning one. And according to your task, you are going to work with the simple classification or regression, go with the simple CNN models. If you are going to work with the segmentation one, go with the UNet or VNet or UNet++. So many models are available that side. Okay.
Thank you, sir. Sir, a question is also sent by Seema Arya ji. How can we use UNet model for detecting plant diseases?
UNet model for detecting UNet model cannot be used for the plant disease detection. You can segment it out. You can, if you can create the data, something similar to that, where you have the segmented area of the diseases, then you can use it. Like, this is not going to use for classification, the disease is there or not. UNet is generally used for the segmentation purpose. Segmentation, it means your image is going to be divided into two classes. There is leaf or no leaf, something like that. So maybe if you require some kind of a segmentation over there, then you can use it. Otherwise, go with the normal convolution method for the classification of your data. You can segment out the leaf area from your image. You can apply some kind of segmentation, so that segment out the leaf area. That leaf area will be applied to some kind of other model for the classification purpose. In this way, you can go with that.
Okay, thank you, sir. So audience, if you have any more question, you can ask. Okay. So with this, I would like to thank you, sir, first for this detailed and interesting information. Now, I would like to invite Professor Miss Deepanjali Dhanu for vote of thanks.
Good evening, everyone. On behalf of IPS College of Technology and Management, Gwalior, I am pleased to extend our sincere appreciation to our distinguished speaker, Dr. Dhirendra Pratap Singh, Associate Professor, Manit, Bhopal, for delivering an enlightening and thought-provoking session on machine learning techniques in the extraction of Earth features from very high-resolution remote sensing images. Your deep insights into advanced geospatial analytics and machine learning, deep learning techniques have significantly enhanced our understanding and inspired us to explore innovative research and practical implementations in this domain. Thank you, sir, for your valuable time, expertise, and highly engaging interaction. Thank you, everyone.
Thank you.
Thank you, sir, for accepting our request. And
Thank you.
so wonderful session, sir. Thank you so much, sir.
Thank you. Thank you. I'm disconnecting now. I'm leaving the meeting.
Okay,
Thank
sir.
you.
Sure, sir. Sure,
Thank
sir.
you.
Thank you.
Thank you for giving me time and listening me now. Yes, patiently.
Thank you, sir.
Pleasure is us, sir. Okay, thank you. Audience, the feedback link is already given, so please fill it, submit it.
Let's reconnect at 7 p.m. We have a validity session, so please reconnect.
And before leaving, there is important message for our participants. The validity session of this FDP will be starting soon at 7 p.m. sharp. Therefore, all participants are requested to join this validity. Stay online means you can join at 6:50 p.m. again. As you know, feedback of last session is very important, and joining of validity session is also mandatory. That's why all are requested once again to attend this validity session. So before
and share your valuable feedback with us. Thank you. Yes, please
Okay,
proceed.
So, okay, audience, see you at a validity session. All are once again requested to join sharp at 6:50 p.m. since our program, validity program, will be starting soon at 7 p.m. That's why. Okay, sir. So meanwhile, we are just signing off, but we will join soon again. Sushil sir, please off this meeting. Okay, let me clear it first here. A question is asked by Dr. Bhairotji. What's about exam? Okay, I just clear it first also here. As we know, after the validity session, the quiz, the exam will be displayed in your Atal portal account at 7:30 p.m. to 8:30 p.m. just after the validity session. So that's why validity session is very important to attend for everyone. So it is humble request to all to attend this validity session just after this at 7:30. The program of quiz will be held. And here it is also important to know this. The minimum qualifying score of this quiz is 70%. That's why it is very important for all of us to solve and submit the quiz properly and within time also. So it is again a message for all to submit the quiz within time. That's why. The other things are also important. After the submission of your quiz, it is also another thing, that is your Atal feedback. Atal feedback is another feedback apart from all these feedbacks of all sessions. There is a Atal feedback also on in the Atal portal. So that's why all are requested to submit first quiz, then Atal feedback within time. It is mandatory to all. The certificate of this FDP will be based on your attendance and score obtained in the quiz. After submitting both, your certificate will be uploaded on your Atal login automatically, so you can download from there. That's why quiz and Atal feedback both are important. If any participant wants to know anything else, they may write in the chat box so we can solve your query also. Yes, the exam time is 7:32, but this will be only displayed after attending the validity session. That's why it is important for all to attend the validity session without failure.
Sir, please repeat the process of uh, examination.
Okay, I just repeat once again for all the members. The very first part, that we need to attend the validity session at 7 p.m. Then after this session at 7:30 the quiz, the examination will be held in the Atal portal. Very important part. First you need to log in the Atal portal. There will be a section that is quiz. Go through that. There is already a quiz uploaded after the validity session. So it will be active after the session. So first you need to log in into the Atal portal, submit, click on the quiz section. There will be your quiz. After the quiz submission, the time of the whole quiz is 7:30 to 8:30. And the minimum passing marks is 70%. The questions are obviously related to all the sessions. That's why solve it properly and submit within time. After the submission, there is a Atal feedback also. A feedback link on Atal portal is there for every participant. So all are requested to fill the feedback also in the Atal portal. Only after both the things, means quiz and this Atal feedback, the certificate will be uploaded and will be seen to you. Any other thing, if anyone wants to ask? Okay. Bhautik Panchalji is asking about the send link of attendance. Attendance of today's program means this session 13. Is it so? Since the attendance is already given in the chat box. Okay. PPT slide of all the sessions. Yes, we have asked to all the speakers to send it. Once it is sent, we have already we have the group. We will upload in the group also, or whosoever has given us, definitely we will send it soon. Okay, timing. A question is asked by Satyen Bansal ji. Timing of participants' feedback. Basically, if you are asking about the Atal feedback, as I have told already, there is a special feedback on Atal portal. That's why we all participants have to click on Atal feedback link and submit it after the exam. That means after 8:30, you may click on feedback, Atal feedback, and then fill the feedback. And sessions feedbacks is already link is given to you, Google Form link of 13, 12, 11, today's all the programs. Once again, I repeat, first we have to, yes. First, we have to go through the validity session. This is very important for all of us. It will be starting soon at 7 p.m. Then
मैंने कहा मैं तो हूँ नहीं बासुदा फैमिली में अब
ऐसा?
ज्वाइन कर दो ना
okay. Panchalji, you are asking once again, not able to see the link of attendance. Give me a minute. Attendance of session 13. If you are asking about the attendance of session 13, it is again given in the chat box. You may find it. As we know all that attendance is very important for all of us. That's why it is the very right time to submit the feedback of session 13. Then Atal feedback will be enabled after the validity and quiz